So Perpetual mechanisms, V1.0, as you've probably read through, is basically about making these kind of looping parametric animations fully within Grasshopper, which Anthony is pretty popular for, and kind of taking that whole thing to just pure Grasshopper, which is really cool to see. You'll learn about perspective tricks and all that kind of fun stuff. So Antoine is he's a lead computational designer at A2M Architecture. Since finishing his architecture master's at the University of Liège in 2017, he's been working as a computational designer in the field of architecture. He's a Grasshopper teacher for architecture offices and a lecturer at the University of Liège. In his community, he's better known for his animations and for co-developing the Tapeworm plugin for Grasshopper. His expertise in computational design ranges from the early stage of design studies to the production of precise documentation for building purposes. So without further ado, I'm going to hand it over to you.
Thank you very much for the intro.
Before you start, I'll be here. I'm just going to turn off my mic and camera. I'll be here if you need anything. I'll be answering questions. And I just want to remind everyone to use the Q&A button if you have questions during the webinar so we can keep track of them. It's a button at the bottom. It's near like where there's, you know, all the other buttons for Zoom. There's a Q&A button. You should ask questions there about the course so we can keep track of them. Cool.
Great. So, hi everyone. First of all, thank you very much for joining me. I'm really happy to see you all here from around the world, as I can see. So here, I'm in Brussels. And so today we're gonna be covering the latest like a series of animation I've made. And yeah, we're gonna go through all the steps and like how to think of how building stuff and then how to animate it. And then also we'll be covering how to render it with V-Ray. And hopefully if we have time, we will as well build up, like gather all these images that are created, and then we will make an animation with them with the small plugin that I will just show you after. So I'm gonna start off immediately by sharing this screen. Yes. So up. I'll start with this. So hey, welcome. So you've seen this obviously. So today, yeah, this is the series, the animations that we're gonna be covering. So as you can see here, it's like what I call a small glider that goes down some rails, and then you can see that the camera is moving, aligning itself so that the glider can basically jump to another rail without being noticed that much, at least by the viewer. So here the pipes are not moving. It's really just the camera that rotates and align its direction. The other one here is like without the trick of the perspective, but it's the same. Can I stop it? Yes, but it's the same concept with a bunch of gliders going around. We have some rotation of the camera just for reflections and stuff. And then here on the right is the trickiest part of this animation, which is having columns that will align here, as you can see, just at one point in the whole animation. The rest of the time, they are not connecting to anything. They are just part of the decoration, let's say. And but still, we connect at the right moment in the right direction for each transition of the glider. So this part, yeah, will be a bit more tricky, but we'll be covering it as well. So here's the full definition. the first time I made a definition that is this pretty. Usually it's a complete mess. So it's pretty big for the time we have. So as you will see, like the whole structure of the code is already in the empty file. And what we will do then is go inside of each groups and basically add the code inside of these groups, and then like the data will be sent at the right place for where we need it. So I think that way everyone can follow. We can all have roughly the same code, and there is no problem with going maybe a bit faster with the code. So here they are also separated with color groups. We have here we will build the principal shape of the rails. Then we will like position the rails in space, in heights, and in X and Y direction. We will create a fake gravity effect. I don't know if you noticed in these animations, there is also like a fake gravity. I say fake because it's not a simulation. It's not like something with kangaroo or anything. It's just really, we create a fake effect, you will see. Then we position the curve again because we will have basically to duplicate it for looped animation. We will create the gliders geometries and position them at the right place. And then we will automate the camera movement to align properly at the right time. And then the two last, the purple and the red one. So these are a bit more tricky. Hopefully we have time to code them all together. If I see that we are running a bit on time, I will actually just start a timer quickly. Hop, hop. We will just go over it. We will like open the finished definition and go over it and explain, but without maybe coding them, so that we can gain a little bit of time. I will still answer any questions even after the workshop. If you ask me a question on Instagram or by email, if you received mine, I think so. I'm happy to reply anyway to anything. And then yeah, we will create like the columns that will align at one camera position, and we will have to filter them. You will see why. And then the very last part, this one we will be doing together whatever happens, and this will be basically rendering. We will be rendering one image, but I will also show you how to render an animation. So this is V-Ray, and it's still inside of Grasshopper. So let's go ahead. I'm going to be covering a little bit what's inside of each group as we enter these group colors. So for example, right now, this will be covering these groups. And so I'm going to explain a little bit what's going on with the presentation here. And then we will dive into it, do all the pink ones, and then we will switch to another group. I think I've been asked to remove my camera for this when it started. So how do I do that though? Huh. Anyway, I'm struggling with this here. I'm confused. I might keep it. All right. So here is what we will start with. So as you might have seen, there is like one rail that is an helicoid rail, and there is another one that turns around that helicoid. So first we will create like a set of points here. This is plenty of points. And then, so this is one group of points that rotates 2 times. And then we will duplicate it above and under. So we will have basically three times the set of points. From that we create, that's here that I can, yeah, great. So we will have the 3 curves. Then we will basically extract the one in the middle. After that, we will create a lot of planes. And these planes will be used to create the second curve, because what we will do is we will twist the planes as we go down the curve. And so that we can basically move the origin of the plane into the X direction of the plane. And since all the planes are twisted around, it will move them basically in circles around that first curve. So we will end up with a second curve like this, and then we extract here the green one only. Okay. And so we will end up with these two curves. All right, so let's dive. I think I have to, yeah. So let's go ahead. Let's go ahead and start. So as you can see, this is like the structure I was talking about. It's like everything is sort of ready with numbers, so that we can refer to groups as numbers, which will be a lot easier, I believe, for you to follow on, and also for me not to get confused to where I should go after, because since it's quite a big definition, if I get lost at some point, even tiny bit, it will have a quite big, might create bigger problems later. So, and after that, I don't want to go through debugging live and stuff like that. It's never good. So yeah, here we go. We have a set here of variables. Basically, when they are in blue like this, it means that you can tweak them as you want. So first of all, we have to create first a set of points for the helicoid curve. Okay, so here, what I call first is a construct point, because we're just gonna create a set of points. And so we're gonna move them from in height. We have a certain height that we're gonna move from. We have the variable here, right? And we want to move them like all, you'll see with range, it will make sense as soon as I show. We have a range, we have we use the height as a domain, so it means that we will create points that move from 0 in height to 45. And then we will also set a number, let's say 1,000. We connect these two. And so we have values that goes from 0 to 45 here, because the height is 45. And we can connect that in the Z. So what we have now is this. Nothing fancy. And then we will use another range. I'll just disconnect them. The number of element in the range will be the same, and we will feed that into the X and Y direction. So how I did here, instead of creating a point and then make it rotate around with a rotate component, what I used is simply like a sine and cosine, sine and cosine here. Not this one, obviously, cosine. And we use these values to create the point. Okay. So as you can see in the PowerPoint, we had to decide how many times we want the curve to rotate, and we have here a variable that is basically that. It means how many times the curve should rotate. We said 2 times. So in a radian value, a full rotation is 2 times pi. So you can simply write it like this. Okay. And we multiply the number of rotation by 2 times pi. So this is, we want to rotate 2 times, and this is a full rotation, basically. And we will connect this into the range. As you can see now, if I go in plan view, we have the points that are rotating around, okay? But it misses something, is the radius. The radius is a value of 1 right now, because sine and cosine only creates value between 0 and 1, right? So what's left to do is just multiply these values with a radius, which is a value that we have here. We can multiply this cosine here, this sine, sorry. We connect this here, and then we also create a duplicate of this one, and we connect the cosine here. Okay, I hope that makes sense. And so if I move the first radius, you will see that it will reduce. If I change the rotation count, you will have different, okay? And also the height, obviously. Okay, once we have this, you can connect it to primary points. So these are the points for the first curve. And what I also want you to do is to connect. I know this is a bit stupid, this one, like 2 times pi, you can connect it to that. We will need it also further away, so let's do that. And the step count is the number of points we have created. So these are, yeah, 2 values that we will be using later, so let's just connect them. Okay, so basically the animation will go like, we select basically the points. We will select 1 point every time, and we will go down the list. That is how the animation will go. That is how the glider will go down, basically. We will create the glider based on 1 point that we select through the list of the points. So right now the points are ordered in the wrong direction. We have the list goes from the bottom to the top. So let's just reverse it. And so now the first point, you can see it here, its Z coordinates is 45. Okay, let's go ahead to the second one. Let's create one triple curve that will be later chopped. So let's go ahead. We will have to move the points up and down. Basically, we can move them twice up or twice down. It doesn't really matter, but it's better to keep this one as the center piece, and then we have geometries above and under. So this will, like, if I do, don't do this now. If I do, it's interpolate curve. Yep. If I do this simply now, and if I mask this, you see the curve here. Actually, the curve is not really, how to say that, the curvature of the curve is not the same at the very end of it, here and there. So what we do, we will duplicate above and under the points. We will then create this, and then we will chop it back to this side, to this size, so that we can ensure that the tangents here at the end will be in the correct direction. It might seem unnecessary, but it is actually for later. So to move it up and down, we need the height, and we need to know how much we have to move it in above and under. And so we will create a series component. We will start with the height, and then we will move down. So negative. We'll use the height as the step, and then we will say 3 times. So if you look here, what the values are produced is that we will move the points up above, once, and then we will move them by 0, and then we will move them by minus the height. It's important that we do up and then down, because as you remember, we will select the points from top to bottom for the animation. Okay, so let's just create now the Z vector, and these will be the vectors to move the points. So the points are in a list here, and we want to move them by all the vectors. So here you can see it's absolutely not what we wanted. And that's because you want to graft this one to have all the points moved, like all these points by each of these vectors. And then we can just flat again these down. And so we have like a bunch of points. Before we interpolate them again, do I have, no, I deleted it. We want to, like, we will have duplicated points here. Let me check actually, interpolate, if it creates a problem, like a visual problem, if we can see it or not. But it seems like it doesn't even want to create them. It's probably because of the duplicated points. And so to remove the duplicate points, I'll just use the create set component from Grasshopper. This works with the points, like it goes and reads the coordinates of them and then delete them. So as you can see here, we had 3003 points, and now we have 3001 points. So basically, we had the point that were here, that was here. Like the first one got duplicated with the last one of the curve under, etc., and here above as well. So now we can use them to interpolate the curve, and we have our triple curve, triple first curve. Okay, this variable here, the 3, I would like also you to just pass it through. This is a static variable. It's nothing that we will not tweak that later. It's just really to create the first shapes. It's just that we will need that later as well. Let's continue. Let's go now to the third group here under. And so here we will basically cut this this curve to find back, if you want, like this only one time the points as one curve. So to do so, I'm just gonna, here we have like the primary points, so just what I showed, and we have the triple curve that we just created. So to do so, I'm just gonna list item here. You wanna grab the first point here above, and you want also to select the last one. So just zoom in and you can click here on the plus and then minus. I want to merge them together so that we have both of them in a list. As so, and then we want to project them. It's a curve closest point. So this component, oh, I see I have questions. I don't know if I should. So once you have this one, I can do this for the ones who want. So it's in curve and then analysis. So we have our 2 points and we have our curve. And so now, I mean, the points are not moving, okay? But this allows us to get this information, the parameters, like where the points touch the curve on the domain of the curve, if you want. And so right from that, we're gonna shatter the curve here. gonna grab the curve and you're gonna use these parameters that we just created. So we have two parameters, and so it creates three curves, right? It creates a curve above, the middle, and the bottom one. And what we want is the middle one. And since here I explained, since we always have three curves, we will just make a list item again and select the first one only. Like we can do that without creating any sort of trouble later if we tweak some values. Okay, so now if I turn off all of that and turn off this, we are back with this. And now we are sure that this tangent here at the end will be in the exact same, in the exact right direction. When he zoom on plugin, yeah. So when I zoom on the plugins, there is like here all the data about what comes into the component. This is from sunglasses plugin. So it comes in it's on foot for Rhino. It's Daniel Abalde, I think, if I'm not mistaken, his last name, who made this. And yeah, it makes it easy. It also displays like the names and stuff. At first, I have to say I was about to use bifocal, but for some reason it stopped working. So I had to, like really in the middle of the way of creating this, it stopped. So I had to switch. Okay, so now we have our first curve. Now let's create, if I'm right, yeah, we will create a, you can turn it off now, this one, we don't need it for now. We will create now a bunch of curves, a bunch of planes, sorry, along this plane. We will then rotate the planes around the curve to create the second curve that will be like really rotating around all of the first curve. All right, so first of all, we will evaluate this long curve with a bunch of, like, create a bunch of points along that curve. So evaluate curve like this. You have the triple curve here. You have the step count, which is 1000. And we have also the number of time this curve has been duplicated. So you will evaluate this curve, and here what you want to do is create a range again. You can connect that to this. You can also here a good measure is always to reparameterize your curve. It's always something. I mean, it's not always wanted, but most of the time it is wanted. So in this case, if something is wrong, check if you reparameterize the curve. So since we did it here, we don't need to do it here. I can do it anyway. It doesn't change anything. And so now we have like 10 divisions, okay? And what we want is basically the same number of points as we had here. So let's just multiply the number of step count by 3. And so we have now 3001 point created. All right, from this, so some might ask, like, why am I creating these again if we had it at the first place? It's true, but at the same time here we will receive the tangent at each point, and that will be useful now to construct. Construct plane, and so we will use these centers. And so if so like so, we will use, so these for now, the planes are horizontal, okay? I'm gonna use the tangent in the X direction. So now the planes are like the X axis of the plane is aligned with the curve, with the tangent of the curve at that point. Okay, as you can see, it's a bit like out of control in terms of the other axis. And so what we're gonna do here is we're gonna try to force the Z direction for the Y axis. And so when I say try, is that like in a plane, the axis always have to be, I mean, in these kind of planes, all the axes always have to be like 90 degrees, okay? So if your first direction of the plane is going down, and then the second one here under, we try to go the Z direction, it will basically go as close as it can. And so it will, you will end up with a plane like this, basically. It will try to go into the Z direction, but it will make it like so. And so that's what we're having here, as you can see, okay? Like the planes are, the Y-axis tries to go as vertical as it can, but is not going vertical. And that's exactly what we want, because we want to align the planes to the curve, like really perpendicular with the tangent. So yes, here after that, what these planes basically will be to create, so the second curve. So we want stuff to rotate around that plane. And so the planes right now are not correct, like in the good orientation to do so still. You will see in a moment why I say that. So what I do usually to reorient a plane, it might sound silly as well. It's a kind of a neat small trick. It's just you deconstruct it, and then here you can reconstruct the plane you want. So here basically we want the planes like so. We will use the Z, so the Y coordinate becomes the Y axis, sorry, becomes the X axis, and our Z coordinate axis becomes the Y axis. So what it means is that it's basically perpendicular frames, like properly aligned, with always here the green axis, so the Y axis always pointing outward. And so here we have all the planes that that we need, and these are what I call the initial planes. So we can just simply connect them and proceed. All right. If we go now to the sixth one, we see here that we need a value that is not there. So that's why not there yet, we have to create it. So that's why we will first of all go back a little bit in the code and come here. So basically, here we will create a small bonus into the settings that we have with the animation, is that the curve will be, I'm gonna show you, can I show you quickly? I can show you quickly. So here is just like, don't panic, this is the finished version. I'm just gonna show you what it means. So we have the second curve and the first one, okay? And what we wanna do basically is have a setting that allows us to make the curve, there's the camera moving, sorry for this, I'm just gonna up, come back here. So look at the curve that goes around all of them, around the first one. We want to have the option to create a small different one. And this is only made by basically rotating the points into one direction or the other. All right. So if we go back here, we have here flip rotation. So it will be a yes or no. If you look here, what's inside of this is simply 0 or 1, so yes or no. And so we will have a filter that will, from this variable, pick either the stream that is 0 or 1, okay? And so the rotation count is a number. For example, we want to rotate twice around the curve, we want to rotate 3 times, etc. Here we want to rotate 3 times. And basically, if we want to flip the rotation, we will simply say that we want to rotate with -3. So here we're just gonna do negative. And so if you wanna rotate, it will be a yes. If you wanna rotate, so it goes into 1. And if you don't wanna rotate, it is 0. And so for now, it says flip rotation, no. And so as you can see here, it grabs the stream 0, which is 3. So this creates like the variable that we were missing. We go back to the group number 6. And here we can start building all the points for the second curve. So how to do so? We will grab a rotate component here. We will have, so we have all these planes here. What we want to do is to twist them, like to rotate them, rotate themselves basically around, rotate them around themselves onto that curve in place. So we will rotate them around themselves, right? Let's just do like this. And then here we have to find by how much, okay? So we want something that is, again, with a range, because we want it to be gradually from 0 rotation to a certain number of time. So like so. And yeah, so we have basically the number of time we want to rotate. This value here describes a full rotation. So you can already say here that we will just multiply that because we want 3 times a full rotation. So we have here a certain value. And then since we also duplicated the curve down and up, so we have 3 times basically. We need to rotate 3 times more, basically. That's what it means. So here we have this number 3 that is simply the value 3 inside, basically, that we connected earlier on. So this will create, like, this tells us what's the maximum rotation that we will have here under. And the first one here will be 0 rotation, and then we will go down, it will increase the rotation, and then down there we will have this maximum rotation, so 18 times pi for now. Sorry for the French accent right there, even though I think I have it every time. So anyway, and so we still have to decide a number of time. The number of time we want to basically is either the step count times either the step count that we had earlier times 3, or we can simply also take like the list length of this, because we need to create the same number of angles than the number of geometries. So here you can either multiply. I think in the finished version of the code, I used multiply here again, and you can connect here. So here it will ask for 3000 steps, and so it will create 3001 values. That's how the range work. It always starts at 0. Yeah, and so now we have here planes that basically wrap, like twist around, as you can see. There are a lot of them, so it might not be the easiest, but you can see that they are twisting. And so we have them, and now let's move create the second curve, like create the second points that we will use for the second curve. So we'll deconstruct the plane. So basically we will use only this plane to create the next curve. I'm gonna maybe, let's keep it on. So we have points here, we have the origins and all the directions. We will use a move component to move the origin of these planes into one direction. Okay. We will use the Y direction. It's I think we could have gone for another one. It could actually maybe even be probably like a nice tweak settings, but let's just use the Y direction. And we're gonna use the right direction. So if I do this here, you will see that the points rotate around the planes, right? I mean, with the planes, but around the first curve. If I turn off this, you can see it turns around. But what we want also to have is a second radius. Okay, so here is a second radius value that comes from really the beginning, so you can tweak that as well. And so we will basically multiply the vector with the value. And so it will create vectors that have the length of that value. And so when you connect that now, you can see that it is way more pronounced and you have like this curve rotating around. So once again here, I'm just gonna show you what it means to flip the rotation. Yeah, it will create something that looks, I tend to prefer this design, but it's really personal, I guess. And so you can also change the number of rotation and you will have complete different shapes as you can see. And also the radius is obviously, you can have like different stuff like that. So now I'm just gonna leave it like so. Let's go ahead and do the, so here now that we have these points, let's connect them to the all secondary points, because these are the points for the second curve. Let's just keep them on for now. So let's see here. Yes, okay. So here, now what we want to do is, let's start with the 8 a little bit, and then we will see what we need, and we will do what we need in the group number 7. I think it will make more sense like that. So here I'm gonna do again interpolate curve up. You use all the points that we had. So we have now this marvelous curve. And what we want to do is the same as we did earlier on in the code, which is here. We want to basically select the first and the last, like we want to select basically 2 points in the set of points that we have. And then we want to project the points to that curve and then shatter the curve to get the first, like the chopped version of that curve. Oh, that's not the right button. Where did it go? Where is my grasshopper? Is this one? Yes, and what's that one? That's nothing. Okay, I apologize for that. So here we have all our points, but we have 3001 of them. We want to find the ones that will basically chop this curve, that will allow us to chop the curve. So I'm gonna just disable these. Okay. So to do so, basically we will need a list item. We will have something like this. And then here we will connect them like so, but we don't know like which number of points, like which index of the points we have to select. So let's go a bit down here into the group number 7, and let's just think about which indexes would be good. Like we can just work it out by just thinking a little bit. So we know we have the number of points that we have here are 3001. Okay, and we know that we started with 1000 step count. So here, like 1000 seems awfully like a third of 3000, right? So this actually is where we want to start. So the points go down like so. So we have 0 and then 3000 down there. What we want to do is select the 1000th, I don't know how to say that, the number 1000 and then the number 2000. And these 2 points will basically allow us to cut the curve, right? Yeah. So we have here 1000, the number of the index, and then we also have to simply multiply this by 2. So I do all of this so that it, like if you ever change the number of step count, just to test around with the definition, just to mess around a little bit to see what's going on and stuff like that, it will update. You know, if you create, if I would create here a new variable, like if you change the step count, then the new variable I created by, for example, saying, oh, I need the index 1000 and I need also the index 2000. It will not update and it will create a lot of problems. So when you have a variable, it's better to have it only once in your definition. It's otherwise you will have to keep track of all of the duplicated variables that you have, and that's something that you will forget over time for sure. So here we have the 2 indexes that we want, and you can see already the 2 points popping on the screen here. So we have them here, right? And then now what we do, we project like a curve closest point. You can select these points and project them to this curve. Once again, here a good something important to do is we want this to be reparameterized so that our little parameters value here will be between 0 and 1. Then we will use that to shatter the curve again. Shatter this one. So I never know how to, like it's always a bit messy with cables, sorry. I'm just gonna move this because we need one more component here. We have now 3 curves like we had before. We have a list item now, and we can select the first one again. It will always be the first one because we duplicated above and under. So here it will, like the curve goes down, and so index 0 is above, as you can see. This one, if I 0, 2, if I select the number 0, it's the one above, then the number 1, then the number 2. What we need is the number 1, so let's just put a panel like so that we know it's always number 1 and it will never change. Okay. So, so this is the first set of groups. I have no idea if we are on time, so we will just continue a little bit, and I think a bit later on we will see if we manage to code these ones together, or if we'll just go and explain them without coding them necessarily. Okay, so right now, just to recap, we have this curve, and we have also, if you go back here a little bit in group number 3, we have this curve, okay? And so these two curves will be basically, yeah, the starting point for the complete animation. So the glider will go around this curve. And so just to tell you a little bit already, basically we will create a lot of points around this curve on both of them, and we will select, for example, the first point of this curve and the first point of this curve, and we will draw the glider on it, and then we will select the second point, draw the glider, and etc. We will basically select through the points, and the glider will appear on this, and that's how we will make the animation. I will come back to that because when I was explaining it, I realized it was not that clear probably. I'll just let them on, and we will start going here. So first of all, let me drink a little bit because all right, so second part, I hope everything is okay for now. I hope so. I don't know where it's gone. It seems okay. So let's just go here and cover a little bit what we're gonna see in these series of group. So basically here we will like separate the curve. If you remember the animations, let me just go back here above. Like the curve are separated. So we will basically explode them, like break the curve that we created and move them into the Z direction, and also separate them a little bit on the Y and X direction. So yeah, positioning of the curve part one, and we will have the second part a little bit after, actually maybe after the break. So we're here. So we have our two curves, and so yeah, the first we'll work on the green curve here, the first curve, and we will break it in 4 pieces, for example. But this is also something that you can tweak afterward. Then we will create, we will like get the planes that are at the end of those, like a subcurve. I call them subcurve in the definition. And we will create circles around those planes to find the intersection with the second curve. And so this will allow us to separate also the second curve. If I will show you that this is the only way that we can do it. I mean, there might be other ways, but this is the simplest way to do it. Yes, and then just after that, we will simply move them in a bit randomly, you will see, so that it creates, like I like to play with randomness. It's controlled randomness, but still it allows to have a lot of different results very quickly without manually change everything. And so that's it. That's all we're gonna do in this small groups. So I hope you all have installed the plugins that we needed, because this is where we need a nice little component from Heteroptera. Is it this one? Yes, it is. Actually, I don't know where it is. I'm just gonna call it. Yeah, let's just call it here. It's called careless range. So let me call range as well to compare. So a range basically will give you like uniformed like values that will range from 0 to a certain domain. So here it's from 0 to 1, but you can see that it's going at the same pace through all the list. Like it's always plus here 0.01 because we want 10 different values, right? As of this one, so the domain is also 0 to 1, but the values you will see are a bit more confused. And that's because this component allows to have a little bit of randomness into the creation of those values. And this is controlled by errancy. I don't know if I could pronounce it correctly, and a seed value as any randomness as a seed value in a computer usually. So here I'm just going to show you that like the errancy is basically a value from 0 to 1. So I'm just going to create a slider here, and you can see if I go down to 0, we have, so it means like no, how to say, no randomness into the distribution of into the creation of the range, and you can go up to 100, like 1, so maximum randomness. And so after that you have a seed, and so the seed you can simply create a number of different values. Okay, so this is just the difference, and that's a really neat component that I use quite a lot. There are plenty of really great components in that plugin here, Heteroptera. And so careless range, I'm gonna code it again because I deleted, I don't know why. And here you'll see that I already placed a bunch of variables that we will use. And here we start with this one. We want to divide the two curves in 4 pieces. We have a certain errancy value, and this is not correct. This is the seed. My bad. This is the seed value. And so we have our careless range here, and we simply say, oh, we want a range with like, it will create 5 values, but it will mean that it will chop the curve in 4 pieces. We have our errancy and we have our seed. Okay, now we can connect this to first parameters, and we will use these parameters to cut the curve right now, actually. So we have our first curve that comes here, and we have our parameters. Let's simply shatter all of them. Simply use like so and like so. I'm going to show you here what we have now. If I'm just going to use a list item to display it. So now we have one curve here above, and you can select through 0 to 3, because I know we have 4 curves. What? I changed the value? Anyway, let's put it to we have to reparameterize this. Yes, we have to. So the curve here wasn't reparameterized. I thought it was reparameterized before, but it was not. So always a good thing is always to reparameterize the curve. Actually, we will also reparameterize already the end so that it will become more handy later on. So we have 4 curves here, 4 subcurves. And so as you can see, I select the first one here, and then I select the second one right there. See the green one? I don't know if it's easy to see on screen. And then the next one, and then the last one, okay? If I go here and do only 3, now we will have only 3 curves, 1, 2, and then 3. If I go further, we select back the first one. Okay. So let's go back here and let this be 4 so that it's the same for everyone. Because like I would suggest to keep this value and maybe some others the same as they were, because you will see at the end we will go through some data tree structures, and like the data tree structure will be based on the number of curves that we have, the number of times we duplicate the curves, etc. So yeah, that will be a bit of a probably the hardest part of it. But yeah, we'll go through, and hopefully I will explain it as best as I can. All right, so we have our first curves here. What we want to do now is we will continue creating a bunch of values here that we will use later for the to separate the curve together. So first of all, here we will create a list of random values to move that we will use to move the group of curves away from each other. So what I mean by away from each other, let's go top view. Basically, we will have like a part of the two curves. We will want to move it away from the center. And then another part, we will want to move it away from the center and away from the center. Okay, so it's just to place them in space. And then here under in the group number 12, we will create Z value. So vectors that will go in values that we will use as vectors to move the curve into the Z direction. So it's basically just to separate these parts of curves that we created. So I'm going through that order. I mean, it might sound a little bit like confused right now, but it's better. Like I found it better to go like this. I mean, and then when we will use them, like really shortly after, it will be completely normal to you. It will appear completely normal. So let's go ahead here first, the 11. So X and Y value, we want to create basically, so we will have curves and we will always move them away from the Z vector, the absolute here, Z axis of the plane that we have here, okay? So we just want complete random values, which will be the length of the displacement from the Z axis here. So we have our random component here, and we have a number of subcurve count. We want the same amount of, so we have 4 curves. We want to create 4 random values, basically. That's what it means. We have a minimum displacement and maximum displacement. These are values that you can tweak from. It will mean basically that the highest possible displacement will be 5 and the minimum can be 0. So maybe some curves will not move at all away from the Z axis here. And some of them will move up to 5 meters. I'm working in meters, by the way, I don't know. So just here, construct a domain for the random values. We have the minimum and the maximum, pretty obvious. We just connect these to these. So now we can create values from 0 to 5, and we ask for 4 values with a subcurve count. And we have also this late one, this last one, just a seed value so that you can like modify these really rapidly. And so it will move the curve later. So you can see the values are just simply changing. And you can connect that to the X and Y values. So we will use these values later to move the curves. Just here in components in the group 16. Here under, we will do something a little bit the same for the Z direction, but there is a small difference, is that we will use, again, a component like this one to have some sort of, it has to be, how to say that? It has to be, it has to be created with a range. It will make sense just right after. Let me show you. So we create a careless range again, careless range. We have max displacement. I could create here a domain it's not needed actually. If you connect, maximum displacement will be like the, so I want to explain this a bit better already now, because you might be wondering like why we would take this one instead of that one. So I think it's better if I explain it already. So basically the curve here that you see, so they are separated. Can I see them already? If I take this component, I should be able to see them already. So I'm just gonna connect this here and display that. Yeah. So we have here, so for now we don't need to see this second curve, okay? So let's just speak about why we need this component. So if we use a component like this one for moving these curves into the Z direction, basically we will create, you see values like here, for example, 3, 4, 3, and 2. Okay, so it means that this curve will move by 3 up, this curve will move by 2, and etc. Which means that we have no guarantee that this one, like this one, can end up higher than this one. Basically, if the red one moves up to 2, like 2 units, and this one moves by 5 units up, it means that this one will be above the red one, which is not what we want. First of all, we could sort the random value and then, but it's even not what we want. What we want here is that here the bottom curve doesn't move at all. We want it to stay there. We want this value, this curve, to move a little bit, this value to move a little bit more than this one, and we want the red one to move a little bit more than the purple one. And so if we use this careless range, if I connect everything here, so max displacement as domain from 0 to here 9.1, which is 9.81, which is just something that you could change after as well. We connect the errancy displacement and the seed. What we will create here is like some values like so. And so the first curve will not move, then the next one will move a little bit, the next one will move a little bit more, etc. Okay. And for the ones that are have the correct like a good vision already of what's happening, then the order of the curves is the orange one is the first one, and then so index 0, index 1, index 2, index 3. So we want the index, apologize, this is the exact opposite. So this is index 0. So the glider will go from up to down. So this one is index 0. So if I select here, list item, if I select this and hide the colors a little bit, here if I select, you see index 0 is the one above. And so we want the one above to move by the maximum, right? And we want the last curve to move by 0. So here it's the list is in the wrong direction, so we just want to reverse it. We could have also like changed the domains and stuff, but yeah, I think it's easier to understand like this. And so we can just connect these here. Thank you. So let's continue here. So here, this is a small group that might bring some confusion if you are not already confused. I hope not. So depending, what did I write? Depending on the use, we need 2 different lists. Oh, it's not even updated. Apologize. I will correct that. So basically, we have four different curves, subcurves here. Okay, but we have 5 different values to move them. And so why is that? Basically, we will want to move the 4 curves by a certain distance. And then we will want to duplicate all the curves, again, above and under, just to have like this nice continuous things that we have here. For example, here, if you look here at this curve there, it's the same as the one here under, okay? So this one here is the same as this one. It just has different colors, but here on the right, this part is the same as this one under. So you kind of see here's the same, this one, and obviously the left side as well. So you kind of see that we will need to duplicate these subcurve above and under, right? Otherwise, when the glider comes here, it will just disappear and reappear here, and you will see that the animation is not really continuous, like seamless. So let me just show you a little bit later with the completed version. I will explain in a slightly different way, and it, for the ones that didn't get it, which can be totally normal with the way I explained. So these are the curves that we will have once we move them into the Z direction. So you can see we have 4 different parts, and this one didn't move. It's still starting at 0. And then we move this one a little bit in height, this one a little bit more, this one a little bit more. You can also see that they moved away a little bit from the center, a little bit. So these are by the values that we just created. So now, why do we need this extra value that we have here? We have 5 value, 4 set of curve. It's because we will also duplicate it, as I said, above and under. So I'm just gonna take the front view. Yep. So here it is. So we can see here we have our 4 curves. We have the red one, purple, green, and orange. Okay, and then we have it duplicated above, like red, purple, green, orange, red, purple, green, orange, etc. And so this last value that we have down here, this extra value, the 9.81, is basically like you take all these 4 curves and you have to duplicate it above at a distance of 9.81, and you have to duplicate it under by a distance of 9.81. So that is why we have this extra value, and we here split it basically. We will split it, just have this maximum value and the list of values that we need for one group of curve, and this maximum value will be used to duplicate the whole group above and under. So let's get back here. I hope this is a bit more clear. So here we have we will use a split list. Yep, split list. We just connect this to that. We just need one. We need basically we need to extract, to split after the first item. So it will give us the first item of the list here, the max Z, and now we have the 4 values. So these are the 4 values to move the 4 subcurve that we have. All right, that was a bit of a tricky one to explain. So now we will just continue with the number 14. What we do at the number 14 is finding the intersections of the on the second curve. I'm going back to this. Okay. So we have here the parameters. Oh yeah, I did like that. Okay, why not? So we can just use perpendicular frame, perp frame, for example. This one. You use the first base curve and you use the parameters here. So if it turns red, it means that I didn't do what I suggest you to do a few times already. So it means that the parameters are not within the domain of the curve. So it means that basically the domain of the curve has not been reparameterized. When you reparameterize, it means that the domain is like set. The domain of the curve is set back to from 0 to 1. And here are our parameters that we created here with the careless range are from 0 to 1. So it meant that the domain of the curve was smaller, for example, in this case. So we will have these planes here. We don't care about the orientation they have. We just need them to create circles. Yeah. And let me display also the second curve that we have created here in group number 8. You can just display it. Here it is. And these circles that we have are way too small. We want basically to intersect these circles with the second curve. To do so, we have the second radius variable, which is right here, given to you. It's also a variable that you can change because it's basically the value we used to create the second curve, okay? So we use that value to create the second curve, and now we use it again to create these circles. And so, yeah, basically these circles are touching the curve at one point only. It's possible when you will change some values in the definition that some like really precise position will create problems. But like you will see 99% of the time it should not create any sort of trouble. And so here, so next component is one that we cannot call, or I never find how to call it. So we have to go, we basically want to intersect these circles with the second curve. So we'll go to the X tab here, it's intersect, and we will go to here, physical curve on curve. So it's usually a more heavy component on the like computation time, let's say. But in this case, it's really like, it's really light because we are just performing like 5 intersection, sorry. So it's really, really light. Here, once again, let's just reparameterize. I mean, it's not even needed to reparameterize this one, but I just do it. It's more of a reflex than anything else. And after that, we will use, so we have the second base curve here that we intersect with our circles, right? This will create a set of parameters, and we want to get the parameters from the second curve here, not from the circles. This one we don't care. We don't care about where on the circle it intersect. We are interested in where on this curve that goes around it intersect. So we're gonna use these ones, and we're gonna shatter the second curve here. Second curve. Again, let's just do it so that we are sure. And you want to connect these here. So right now, here, this will create some weird results here. What happens is that we don't want it to be in a tree. We just want it to be flattened. And so that we will just create 4 curves. And so let me just show you with this duplicated here. So we had the first one. I'm just gonna very dirty, in a very dirty way, just duplicate it. And here you go. You can see now that we have our curves that are separated and in the same order, like in the same direction. Like first index will be the red one, then the purple, then the green, then the orange. Okay. Let's delete this. And we can connect these, the second subcurves, also here before we forget. Once again, we created curves. Let's just reparameterize it so that later we don't have any troubles. And we want also the second parameters. I don't remember why for now, but I'm pretty sure it will become Andy. Obla. Oh, this is not a good. Yeah, we will. Ah, yes. Okay. You will see why. Basically, when we will create the fake gravity, like the impression of gravity for the gliders, we will have like a bunch of planes, and then we will have to like find on which curve are the planes. And so that's why we need the second parameters later on. Anyway. Okay, so we have divided now both of our curves. Let's just turn this off. We might just keep this on. Here, number 15. I didn't even left any notes, because I mean, probably just by this you can maybe guess a little bit. We just want them to like regroup the curves 2 by 2. So let's just call component here Antoine, which is not how to pronounce my name, by the way. Some people call me like that. And so here we will have like 2 branches with 4 curves in it. And so the first branch will be the curves that are the helicoid curve, the first curve that we had. Okay. And so 4 subcurve in that. And the data in the second branch will be the 4 subcurve that are along these zigzaggy curve. We can connect that to this, and that's it. Here you can see that there is like I mean, it's not even necessary, but you see that there is a structure that is unused. Like the first one, it's 0, 0, and then 0, 1. So you can just simplify this, and it's 0 to 1. Yeah. So now we can mask these. That is not even a value. I'm masking this again. And so we are here with our 2 sets, our 2 curves, which are both divided in 4. Here we're gonna construct now the vectors to, on the group 17, move the curves, like I said, in the Z direction, but also away from each other a little bit, so that after that there will be like this play of perspective when you will move around. I will explain in detail how to make the perspective work, like how does it, some of you might already know it, it's nothing like crazy or whatever, but yeah, we will be covering that in detail a little bit later. So here, basically we're just gonna create the vectors to move away, so that they move away from the Z axis. We are not creating the vector that goes up, okay? So we have the X, the variable that we called XY values, which is the distance that they have to move. And we have the first curves. So as I said, they will move, the curves will move away from the center, away from the z-axis that is here. So let's just evaluate the curve here. Let's reparameterize it. I don't know if it already has been done before, but let's just do it again. And here I'm just gonna put, let's write it correct, like completely 0.5. So I know there is a component also that you might point on curve. Actually, I don't know if it's exactly the same position. Sometimes it's not, because it has nothing to do with the domain of the curve or something. So let's just use this one, evaluate curve 0.5 and reparameterized. So this means that we have basically the center point of each subcurve on the helicoid one, on the first curve that we created. I know I'm using a lot of curve words. I hope it's not too confusing. It was really tricky to call them with different names. Okay, and so for each of them, each of these points, we have now to find a corresponding point at the same height that is on the z-axis. And so that we will create a vector from the created points towards the points that we have here on the curves. So it will make more sense now. If I just deconstruct these points, we have their coordinates, and then if I construct points right after, point like this, construct point, you can basically, what we want is just the z values, okay? And we want the coordinates in y and x to be 0. And so we have points that are on the z-axis, okay? And so with that, we can simply create a vector with vector 2 points, vector 2. And we have our starting vectors, which are not these ones. I apologize. We want to start from these points and create a vector that goes to these points, right? As you can see here on the colors. So we do like so. And here you want, this is, so here basically we created vectors that have a distance. And this is the distance between the points, okay? Which is basically the radius that we used to construct the first point. Anyway, that is not necessarily relevant. What we want here is this vector to have a length of 1. And so that after we will multiply them by this value. And so we will have a vector of length 3.63, one vector 4.08, etc. Okay. So here you can simply right click invert, because by default, if you see here, it's unitized, and by default it is false. And what we want to do is unitize the vector. We want them to be of length 1. So now if I go back here on length, you can see they are all of length 1. I'm just also gonna display just to show you. If I do this, you can see that the vectors have a length of 1. And if I unclick unitize, they have the complete length. That might be more visual. So we want it to be unitized here with true. And then we want to multiply with this value. And so now we have basically, I'm going to show you again the vectors now. So from the start to the end. And so we have vectors here that will go into the direction that we wanted, that we set, with a different distance. And so let me just modify here. You can see that they will have different distances. And then if you want them, you can make them longer, the bottom as well. So these will be used to, we will use them to place like to separate the curve. We will just quickly do it, and then I will read the small question that there is, because if something is not understood right now, it could be just after this. I'm just gonna turn everything off. And now what we're gonna do here is simply move the curve into the right spot, like separate them from so that they don't touch each other anymore. All right, so we will need a move component, obviously. We will be moving curves along a certain vector. So we can see here we have like 2 branches with 4 curve, right? What we want to do is move the curve. We have basically 4 vectors, and here we have 4 curves in the branches. So basically here, I'm gonna just change the structure of the tree. This is not something mandatory for here, but it will become a lot more handy later on. So what we want to do here is just flip matrix, so that we have basically the curve by pair. Okay, so let me just show you what I talk about by pair tree branch. So here it's just a list item for data tree. So you have here path 0, 1, 2, 3, and so you just want to specify. When it's a simple structure like this, you can even just put something like this. And so you see, I want, like, if this is the structure like we had before, we select all the curve of all the subcurve of the first curve, and if we go into the second, we select all the subcurve of the second curve. And what we want is more something like this. We select the 2 first subcurves, sorry, and then select the second subcurve, the third subcurves, etc. So that's why I flipped the matrix to have this new structure that is 4 subcurve and then 2 item in it. One is the curve that is inside and the second is the curve that is outside. And here we want, so we have our vectors here. These are already vectors, and here these are values to move in the Z direction. So we want to create them, like to make vectors out of them. So Z vectors, which simply move the curves above, like in a Z direction. And then we want to add these 2 vectors. So when you add 2 vectors, it basically create, like, if you have vectors in this direction and a vector in the other direction, basically you take this vector, you put it will put it here, and it will create the third vector here. And so we add the vectors, and then we will move it. As you can see here, there is a small problem. Once again, it's just because we have different structure here. We have 4 branches here, and here we have only 1 branch. We have 4 values. Here we have only 2 values in the branches. So we just want to graft it. We have 4 branches, and the 2 curves receive the vector. All right. So I'm just going to turn off this. And so I have something else displayed. Yes, this one. And so now what we have is the curve that are separated both in the X and Y and in Z direction. Let's just connect this to that. And we will also need here the vectors. Actually, let's graft it here because I noticed that we will later on need them grafted. So graft it here maybe, so that we don't have problem later for those who are making it alone. Okay, and so basically here you have already a component that is made, and this allows you to see. Basically, it colors the curve with a component here that is from a human plugin, from Andrew Human. I don't really know his last name as well. So yeah. So that is it for these groups. So we took the curve that we created, we splitted them in a certain amount of like a section, like here's 4 subcurves, and then we move them in space. So the bottom one doesn't move, it doesn't move upward, and the rest move a little bit more each time. And all of them move into the X or Y direction, basically away from the Z vector. So that's what we did here. So yeah, I think now we will go. So what's the time already? What is the time already? 1:30. All right, I might have to try to speed up a little bit. We're gonna go through the green groups now. And yeah, I really think that these, like if we want to render, and like I really want to show you how to render because I think it's really a big part of this animation, these animations, how to render with V-Ray. So this is really important. And these 2 set of groups are a bit less important because the animation will work without them, whatever. Like without them, the animation will work. And so, yeah, we will just probably go through them. Like on this version, we will go through and I will explain a little bit what's going on, but probably after making the render, so that yeah, if it extends a little bit after the end of the workshop, the ones that are interested to really see these parts, I will be covering it. All right, so I go back here. So we will go now through the green ones, and then after that, I think we can do a really small break, maybe 5 minutes. But yeah, I think it's better that we dive into the green ones immediately. I'm just gonna check if there is a, yes, okay, it's already replied. Great, thank you. All right, I'm just grabbing this again and I display it and I drink very quickly. Okay. So here we are, green ones, where we're gonna basically create a fake gravity. So this is already quite maybe a bit more difficult to understand how we will be able to create a fake gravity. So yeah, bear with me. I'll try to explain as best as I can. So once again, we have these 2 starting curves. We go back to them. Don't think about the curves that we just separated and everything, because we will basically create planes here that will be positioned at different distances of each other along the curves, and then these planes we will put them back onto the curves that we just created moments ago, the ones with the colors, the separated ones. So here we will create a bunch of points on the first curve, and then we will want to project them to the closest, to find the closest point onto the second curve. And so as you can see here, I just show you with just 3 selected points what it looks like. And as you can see, I'm projecting them not on the complete second curve, but only on a smaller domain of the curve. So this is basically to like limit some bugs where this point might project to the second curve, but somewhere else. If you tweak some values, it's possible that it goes and projects somewhere else. So here I'm trying to limit where it can project itself to on the second curve. And so we will do that for all the points, basically. So all of them have like a smaller second curve to project onto. After that, so we have 2 points. We have points on the second curve and point on the first curve. And we will calculate what I call the relative z value. So it's basically, we take this point, we check its z value, this is altitude, yeah, it's height. And we take also the first point of this one, we calculate its height, and then we make the difference out of them. And so these two are the same height, so the difference is 0. Then this one is a bit higher than this one. It's 1.6 higher. So, or this one is 1.6 lower because it's a negative value, etc. And so these ones is like, its corresponding point down here is like 9.4 under, etc. And so we calculate that for all the points. And then we will use these values, these created values, to move the points from this position to that position. So this is quite subtle, but you can imagine now that if we go and select one point after the other, like this, when they are uniformly distributed along the curve, the speed will be the same, right? But here, if they are like sometimes away from each other a bit more, and then sometimes they are close to each other, it means that when you will select through all the points, the selection will appear to go slower here because there is more point to select. And then as they go away from each other, it will appear to go faster again, and then slower, and then faster, and then slower. Okay, so as I told you at the beginning, this is how we will make the glider move. It's basically just selecting some planes or some points along the curve and create the glider on it. So yeah, hereafter we will have like a quick way to visualize the fake gravity. So the green is where it goes quick, and the red is where it goes slow. So you can see that here it's not really how it should be. Like this one should be the slowest because it's high, then it should go quick, and then it should go slow, and then it should go quick, and then slow again here above, sorry. And so we will also create like a neat way to adjust this. So this is the only manual setting, and there is also a way to optimize it if you want, if you are lazy, like I can be a lot of time. So actually, it was actually even in my code, even if it's really easy to tweak manually, and it's as precise almost. Yeah, and so here are the new values, and so ultimately we will create planes from those points. And this is the end of that group after that. So let's go ahead. This is this will be maybe a little bit tricky at 1 point or 2. So let's go ahead. So we have our first curve here. I'm just gonna put data so that you see what we're talking about. We have, so this is the curve itself. It's not the subcurves. So you can see there is only one value in it. It's the full curve. And we have our second curve right there, okay? What we wanna do is divide this curve by a bunch of points. So here it's right now. So before that, when we created points and etc., it's just to create the geometry. Now we are creating the points that will serve for the animation, because we will select through all of them afterward. Okay, so we will evaluate this curve again. Let's just reparameterize again. Good reflex, and we will evaluate it by a certain amount And so we'll use a range again, and like so. The domain will be 0 to 1, so that's already correct because we reparameterize the curve. And here let's put a slider that goes from 0 to, actually 0 is a really bad idea. Let's put, I don't know, 100 to 500. Not this one, the n value, okay? Like so. Maybe for now I will let it to 100. So it means that basically when we select through the points, we can only have 100 frames, right? This has to you have to have that in mind now. It's since we will select through all the points to create the geometry, so the geometry will appear on this point and then on this point and then on this point and then on this point. It will never be in between. So it means that if the value here is 100, it means that you will create in the animation, you can only create 100 frames. If you put 1,000, you can have 1,000 frames for your animation. And then depending on the frame rate, you will have the length of the animation, like in time. So let's put 100 just to be able to visualize a bit more, and then we will increase it to, I don't know, 500, for example, later on. Okay, so we have this. We have the second base curve here, and what I said is that we want to project the point not to the complete curve, but more towards like subdomains, like smaller portions of that curve. So there is a component here that is called subcurve that will basically allow you to, like, oh, maybe it tells you something here interesting. Yes, it basically explains it's what's inside here. So you see, you have one curve, like the logo. You have a complete curve, and then you can create a curve that is contained within that curve. So that's exactly what we want. So we will have this, we will reparameterize. So this is the second base curve. And then I will make a little bit more space. We will need these values, but we will create new domains. So you will use, it's the opposite, construct domain here. And what will be the values is basically these values plus and minus a certain plus and minus a certain value. I will write them and then we will check together. So this is the plus, and we need also minus. And so let's just put a very small slider, let's say, so I think in the 0.05 to, I don't know, 0.1. And you can even let, yep, something like this. Okay, so 0.05 to 0.1 with 3 decimals, for example. So basically, you want the domain to start at these values each time for each point, minus that value that we just created, and you want the domain to end to that position plus the value that we have. And so now it basically created 101 curve, which is what you have. You have the same number of points here above. Let me select list item, one of these curves, so that you see what we're talking about. So it means that I will go with a one slider 100. Yes. So it means that basically this point here will be able to project. We will project it like, yeah, project it to this curve, the green one that stops here. And then the next, like for example, the 28th point, we will project it on this subcurve. Okay, and so as you can see, as we go down, like all of them are able to be like can be projected on a smaller smaller subcurve. If I don't do that, I think I can actually show you. I will show you just now. That you will not do it, but I will show you. So curve closest point is the one that we need to project the points on the curve. And so here we have a list of points and the same length of a curve list of the same length. And that's it. If we don't do this, I don't know if it will create any trouble in this case. Yeah, this is maybe a bad example. It looks fine. It looks fine, but if you start tweaking the values, it will appear to be different. Apologize that it doesn't look like a counter example, but really it can, like it. I took some time to figure this out. I have to say. So once we did this, we have the first points here. We can pass that to this variable. We have the second point here. We can pass that to this variable. And here we have all the subcurves, so that are all these smaller parts, and we can pass that here. I'm gonna mask all of this. And so now I told you we have to like calculate when it should be slower, when it should be faster, right? So here we have to calculate basically the relative values between the two, like what's the difference in height. So to do so, it's fairly simple. We just deconstruct the points, deconstruct both of them, up, up, and then we use minus. Yep, minus. You can subtract the ones on the first curve to the ones on the second curve, and you get like what we called earlier the relative z value. So if I were to text tag this text tag, just to show you what it is, it's basically just basically value. So this is almost 0 difference, and then this is 1 meter 70 difference, 1 meter 3 meter 4 difference, etc. So these are the values that we saw on the PowerPoint. Okay, so we're gonna skip this number 22 for now, and we're gonna come back after. Actually, yes, it's just we're just gonna go directly to the 21. We're gonna keep the right order, and then we will see later on why we need. We will come back here later on. That's what I wanted to say. Sorry. So we have the relative z value, and what we want to do is basically like so the relative z value has a domain that we can sort of guess, but not so much. Like we know it's based on the radius of the second curve that turns around the first one, but it's also along a plane that, if you remember correctly, is a bit tilted. The planes are a bit tilted, so they are not going in a z direction, so they are not vertical, I mean, and so we cannot really we cannot really have the domain like that. So what we want to do is like remap these values into a domain that we can later tweak, and this domain will allow us to create basically a set of values to move the point and regroup the points at a different position on the curve, like group a bunch of points where it should be slower and make them like separate them apart from each other when it should go faster. Okay, so we're going to use a remap component number, and we're going to straight up put these values directly in to get the bounds of the first, like the domain where the values are first. We do this, we get the domain. This is the source domain of it, and then we have a target domain. For now it's 0 to 1, but we're going to create our own. So construct domain, and here, like if you basically sorry, if you basically create a domain here that starts at 0, it means that at some point the glider will stop. So I didn't even test that, but I think it will not work probably. Like it will not continue well in the definition. What you want is the minimum speed to be 1. It's just something like it doesn't really have a unit. It's just 1. And then you want the maximum speed to be like a multiplied, like a higher value, like 4 times, for example. You know, so if the smallest speed is 1, this time is this maximum speed, sorry, is 4. Okay. So this create basically domain between 1 and 4. We have this here. And for now, we can connect this here. It's not finished. We will come back here a little bit later with this group. For now, let's just forget it, because I think it will mess around. Like it will not be clear if I start explaining the group number 22 now. So let's go to group number 23. And so let's check a bit what are these values. Okay. Should I keep these points on? I think it's a good idea to keep the points on so that you can see. So basically the relative z value, if I put a quick graph component, yeah, it looks like a sine wave or something, right? And this is like fairly normal. It goes under so the second curve goes under the first curve, and then it goes up again, and then down again, and then up again, and then down again. And so it's normal that the z value creates this kind of graph, right? But what we want to do is use these values to create points that are closer and closer to each other when it's, for example, higher values, then apart from each other where they are below, and then closer again, etc. So we have the first base curve here. We're gonna evaluate. So we're gonna create, like instead of moving these points, we're just gonna recreate them again. And now that we have these shifted values, if we mass addition them, it will probably appear a bit more. If you take here, so we don't want the absolute, like what's the complete sum of the relative values. We don't care. We want to see how it evolves over the addition. And so as you can see here, like there is some kind of, oh, it goes faster, then it goes slower, then it goes faster, then it goes slower. In the y values here, it goes faster. Like if you move here at the same pace, the y value goes higher faster, and then the y value goes higher slower, and then it goes faster again, etc. But as you can see also here, the values are between 2.5 and 252, and we don't want that. We want to have a domain here that is between 0 and 1. So let's remap the values again. Remap the values. We have these values that we want in. We want to get the bounds of this. Okay. This is the source domain, and the target domain we want 0 to 1. So that's already correct. You just connect this here, and we have now points that are created. Let's see what they look like. So this has no preview, and these two have preview. I'm just gonna turn them off, and as you can see now, some of them are closer to each other, right? Some of them are closer, and then it's separated more, and then closer again, separated and closer. So there are different ways of achieving this. This is just, I don't know if it's the clearest. I hope it is for you. There are other ways, but like it's a lot more expensive. Like if you go, for example, with component like evaluate length, this component can be really heavy sometimes. That's actually the one I went for at the beginning. And then when doing this workshop, I went back to something more like faster, so that you can also iterate and make plenty of animations really fast. So we have these points, and now what we want to do is to put them back onto the second curve, okay? And we're gonna do that exactly the same way as this, how we did it here. Okay, so we have a bunch of second, like sub-curves, remember? Like smaller curves, and we're gonna project them onto that. So let's just do that really quickly. We have the points here. We want curve, closest point. If I write it properly, it might be easier. Yep, this one. We have the points here, and we have the subcurves that are right here. So we have already the points. As you can see, they are like closer to each other here, closer to each other there, etc. And let's like give the variables further away. We have the points on the first curve here. So just to be clear, these points, we will create the gliders onto them, and we will select through all of them. And so once again, when we select through points that are closer to each other, like it will appear to go, the selection will appear to go slower, and then it will go faster and then slower and then etc. Okay, so we want to pass the points and we want to pass the tangents. Why so? It's because we will create planes. And so as we did in the pink groups, we will need the tangent to have the planes like aligned to the curve, right? To the direction of the curve. Here, we want, so the parameters of the points, of the first points are these ones. It's the one that we used here, right? So we want that. And then we want also the parameters of the point of the second points, which is these ones, parameters. And that will become handy to, after the small break, to detect which points should be on which of these curves, because the curves have moved. And so we have to move the point onto those colored curve. All right, and so here we need also like the second points and the tangent of the second point. So basically we have the second points here, but I'm just gonna use an evaluate component again. Evaluate. You have the subcurves here, and you have the parameters here. And then you can simply pass that through. Okay, so now we created like something that will be like create some sort of fake gravity as we go. To visualize it, let's go directly down here to the group 25 and 24. Let's actually start by the 25th. The 24, yeah, let's just do it as well after, but yeah. So here, I'm just gonna go really quickly into this. It's not really important. It's just so that you can visualize it. Here we have a bunch of points, which are the points of the second curve. Okay, so it's these ones. And what I'm gonna do is call relative item, relative item, this one. You want to connect this, basically, you want to graph and simplify so that we have them in a tree. And then I want just to type this in a panel. So basically it means that for every point in the tree, I want to select also the one that is a branch higher. This is basically the same as doing like a shift list that is not wrapped, I believe, and then use a cul item. I mean, there are many ways to do many stuff anyway. So here we have one point, and for each point we have a point that is one further on the curve. Okay, so we will create lines of that. So we have tiny segments. It's not a polylines, it's really tiny. If I flatten this, it's tiny little lines. And you can see that they have different distances. And so we will use that to display colors based on their length. So we're gonna call curl length, only length. This. I'm gonna go a bit faster here, bounce, not to lose time on this because it's really just visually, like visual purposes, and you can definitely see that. Watch that after if. So we get the bounds, which are the. What do I want? Take them. The bounds of the length. So we have the smallest length is 0.9. The maximum is 3. And then we will use that in a gradient component. Problem with my gradient component. Right here, we have the minimum value, the maximum value, and then we have all the values, right? And then we're gonna call the custom line component, which is from human, the human plugin. We have our curve that we want to color. Here, as you can see now, they are pink. And we have our set of colors that we go here to the shaders. And so you can see there is some colors. It's not really thick enough. So let's just put, oh, 54. Oh, certainly not. We're just gonna put 5, for example, and this is the thickness. And so now you can see that when it's red, it will go slower because like you can just visualize better than just with the points, right? And so, yeah. As you might notice, like it might seems weird that the glider will go the slowest here. You want maybe it to go the slowest more here, right? So you want to basically shift the relative z values so that it creates points that are closer here, right? So that's where we go back to our group number 22. And we're gonna just create like a quick way to simply, with a slider, move or create these points at different position. Like the group of point here, we will be able to create them a bit more here or a bit more down there, because we will shift the list. Yeah, before we created it. So here it's also a bit maybe more tricky to explain. Basically, what I want is to have a slider that goes from 0 to 1, like so. And at 0, it's the current state. And then we shift through the list. And then we arrive at the end, which will be the same state or something really, really close. So to do so, we have here relative z values. We just use them because we have to know the number of item we have here. So basically, we have 101 item. It means that we want to shift like from 0 to maximum 101 item. So I'm going to call list length. So when I speak about shifting the list, here in the group 21, we will really have like shift list. And we will basically shift the values that we created here, right? And we will connect them here. So in the group 21, the shift value. And this here will be our value with like to shift with. And so when I speak about shift, it's actually a shift component, like it's not something else. So I hope everyone has seen this, like, and so now we come back here. And so, yes, we have 101 value. I'm just let me just disconnect this for 1 second just to show you something. As you can see here, like the curve is red at 1 point, at 2 point, and at 3 point. This is because we ask the second curve to rotate 3 times around the first one, okay? So that is why here you have the number of rotation count. So basically here we have like 100 of point, but for each rotation, we have basically the number of point divided by the number of rotation. So for one rotation, we will have 101 divided by 3. This is the number of points that will appear in one rotation, that will be contained in one rotation of that curve. So we simply divide this. Simply this one like this, like so. And then we will now, with this slider, select through, we will multiply basically this value. So this is a really neat trick when you have like a list and you don't know the length of the list, or you know the length of the list, but you know that the length of the list can change. You can basically just, so this will be the length of the list. And you can simply multiply and go from 0 to 1. And at the end here, what you will get, like if you round the value to the nearest, let me just show you what it looks like. It will basically from 0 to 1, it will, you see, create the index to shift something. For example, or if you just want to select to display it on the screen, for example, it's also something that can become handy. We don't even need the round here. We can just connect this to that. And I'm gonna connect this again. And so now, if you see, we can basically tweak the gravity. Like we can, we want the points to be here, gathered here, maybe a little bit there, right? Let's also display this. And now you can see that the red parts are maybe at the right position, right? If it fits here, it means that it will go slower here. And so it could be interesting, but it might look odd, maybe something. So yeah, let's put it there. Here, basically in the group number 24, it's just something, yeah, laziest way of finding the best gravity. Basically, we can run a small optimization. There is absolutely no point of that. I'm just gonna show you what I mean by that. But really quickly, if we deconstruct the points, the two of them, we can basically calculate the relative, the difference between them, again, the height difference between them. And then we can mass addition that, and we have a total score. Okay. If more points are gathered all the time where they are higher, it means that the global value here will tend to be bigger, right? And that's exactly what we want. We want always the points to gather higher. As you can see, there's more points here than down here, for example, right? So if we calculate, like compute here, the complete z coordinates of the points, it will create a higher value every time the curve is higher, like the red is higher. And so here we can just call Galapagos. We have the fitness is this one, and then you can connect this, the genome, back to this value, which is the value that allow you to change this, right? And so when you run this, it will, if you run it and ask for maximum here, maximize, like it will run like it's a bit silly, but it's funny. So you can see that it will try, the red will start to be more and more towards the top every time. Yeah, that's a funny little way. If you want to go full automated workflow, right? Okay, so before we end up this green section, we have two small groups. Yes, two small, which is basically create the planes out of these points. And so we will do them basically, again, the same way as we did here. So we will use tangents. We will use the points and the tangents. We will create plane. We will try to make them vertical. And then we will deconstruct and reconstruct to have them aligned with the curve. So let's go back here. It will be basically, I believe, yes, it's exactly the same here and there. So let's construct plane, right? We will have first the points. We have the tangent, right? And actually here, what we want, apologize, I said the Z direction, but it's not exactly what we want. We want the second axis. For example, here we are creating on the first curve. We want the second axis to point towards the second curve, right? To the corresponding point on the second curve. So for that, we have first point and we have the second point here. So the point on the second curve, I mean. So we just create vector 2 points. We have our from towards, and then we have our vector. And so you can see now that the y is all, the y axis, the green ones, is always pointing towards the second curve, right? So here it goes up because the curve is above, etc. So you can see as well, it's a bit like they are tighter here and then more away from each other again. So that's exactly what we wanted. Except that we want these planes again to be like perpendicular to the curve, not aligned to it. So we're gonna deconstruct again this small little trick. There might be a better way. I just find it so quick and easy to do that I prefer this. And so we will just take that and use the y as x and the z axis as the other one. And so when you see now, the planes are rotating around and they're going always aligned with the second curve, but perpendicular to the first curve. We can pass this there. And then here we can just basically copy. If I click the right button, yep. We can duplicate these, put it there, and then origin here, the points. So now it's the points number 2, it's the points that are on the second curve, right? And then here, the points that are on the second curve towards the point that are on the first curve. Recreate with the tangent here of the second, right? You just basically duplicate this and reconnect everything properly. And now you have also these points, these planes with, see the x-axis that points towards the second, like the other curve, basically. All right, I'm just gonna check here. Remap, check out Remap Plus for an easy way to remap. Yes. Yes, I'm maybe a bit of the old way. I sometimes just discover a new component. I mean, almost not every day, but every week. So yeah, there might be easier components for sure. So that's it for this green group. So I don't know if it's like, I think it's better to do a really small break, but I think we're also running a bit out of time if I'm not mistaken. So this one will go quite quick, this one a bit longer, and the yellow one will be a bit tricky, but it's also one of the more exciting ones is the camera movement. Yeah, break. I think it's a better idea. You're right. All right. Let's go maybe. Hey, let's go maybe for, I don't know, 5-minute breaks. It's a petite, it's a very small break. 5, 10, 5. I don't know what you guys prefer. 10 minutes. Let's do 10 minutes. Okay. At 40 we meet again. At 40. I mean, it depends for you, but in 10 minutes we will we'll get back. No, it's normal. I guess it's also like complicated to get all this in one go. I understand completely. So all right, see you in 10 minutes. Hey, so I hope everyone is back. I'm gonna wait maybe until 42, and then we'll go. So once again, just so there is no confusion, we're gonna be doing now these blue, purple a little bit groups here, which is basically position the planes onto the curve that we separated earlier on, and the newly created planes, so the ones with the gravity effect. And then we will, here in the lighter blue, we will create the gliders and we will animate them. So you will see what we were talking about like a few times already, which is selecting through the planes and creating the simple pipes basically around them. So in the lighter blue here, and that's it for that part. And then after that, right after it, we will do these yellow ones that are how to automate the camera movement, like to always align to the right direction at the right time, which is like to create the illusion, you know, when you align with the two rails, the thing will jump in between them. And so it will appear invisible to your eye, almost invisible. And then after that, so since we are running a little bit short on time, I will probably not cover that at the beginning, okay? I will let this off because we don't really need that to be able to run an animation and create a render out of it and render also a complete animation. So these are two different, like render an image and render an animation. And then there is also on the cloud and on locally that we can cover. Could be interesting. So that we cover like the most important things that we wanted to cover. And then after that, we should be a little bit still before the end of the workshop and we can go through this, but on the completed version, right? We will go here and we will go through everything together, but we will not like code it because it takes a little bit more time to code it, obviously. And after the workshop, again, if you have any question in this, you can send me, you can ask me, and I will gladly respond. I will be happy to help you out if you are stuck maybe on some part, or if you think one part is garbage and you should have done another way and I should know. You can also tell me because that always happens. Actually, I even simplified it again, few stuff like really late into the process. It always when you code for yourself, you can always get like lost in some stuff, and the obvious path is not that obvious when you code alone, right? So so let's go ahead. I'm gonna get back to this one, so the ones that we've been building together, and we're gonna go here in these blue groups. So I'm gonna stop this camera up, and I'm gonna, no, it's not the right one. I want this one. All right. So this, as I said, is to like position the plane into the curves, on the separated curves that we had before, and also to like duplicate the whole group of separated curves like above and under a certain amount of time, so that you will always have, like on your animation, you will always have geometry above and geometry under. It will not appear like to be disconnected or something. So this is more, yeah. Sorry. So let's go ahead. So this is what we ended up with. We have two curves with a bunch of planes that are along them with the gravity. But now what we need really to do is to detect on which curve these planes are. Okay. Because yeah, we created them separately, and so now we have to define, oh, these planes sit on the red curve, so they should be in the branch, for example, 0. Then these planes are on the curve purple, so they should be on another branch in the data tree, for example, and then etc. The green ones and then the orange ones. So that once we've established that, we can move the planes along with the curve that we moved earlier. So we move them up, but also away from the z-axis that is in the middle, right? And so that we will end up. So once again, this is what we ended up with. And so once we put the planes also onto these curves, we will also take all of these curves and duplicate them above and under. All right. So here, yeah, basically above and under a certain amount of time, once again. So maybe we duplicate it once above, once under, but maybe you want to duplicate it twice above and twice under, so that when you are here, creating your animation, and when the camera moves a bit up and down, there will be always these kind of curves. You will be always seeing the curve under and above, and so you will see the glider coming through the top and then going down to the next one. You know, like it will appear to be connected, because if you are here, you will have like a glider that will appear here. It will go down and then it will disappear here and reappear here and go down. You see? So if you have to duplicate it above and under, that it will look completely continuous. And so we do the same. After that, we will do the same for the plane. So we will have to duplicate them again onto all of the newly created curves. Okay, and so after that, once we have all of that, we will have the structure for the animation that is completely finished. And so we will be able to create the glider and then animate the camera to have, like we will be able to animate the glider already with the gravity, but they will still jump. And so we will align the camera at the right moment and so that will be the next part. Okay, let's dive into it. So basically where we left off for now is these, whoa, I'm gonna, no, we have these 4 curves, these 4 group of curves, let's call them like paired curve, I think I call them. And what we want to do is to, so remember, these are the ones that are moved already. We want to know which planes of this should go on which of the colored curve that you saw earlier on. So what I'm going to do here is I'm going to, so just for visual purposes, for you to understand a bit better, maybe, I'm just going to take this and connect this. You don't really need to do so. So like so, we don't need this one for that. Yep. So as you can see here, yeah, these are the curves that were not moved yet. All right. So basically we created these subcurves with a certain, if you go back here, with a certain parameters, okay, that goes from 0 to 1, and that's where we split it the first curve, and then we here with the where it is here with the intersection of the circle, we found second parameters to split the second curve, the one that rotates around. Okay. These two values, we've been like sending it to the, I don't know, the spine here of variables, and they will actually become really handy now because we will be able to create domains out of them and then evaluate the parameters value that we have here that helped us create the planes, and evaluate in which domain they land, in which domain they exist, like they fall. So here we have parameters that goes from 0 to 1. These are the planes, okay? And here we will create with these first parameters that helped us like cut the curves. We will create 4 domains and we will test basically the parameters of the plane into those domains. Once again, really complicated to explain, but might be hopefully better in when coded, when you can see the data and how it's structuring itself as we go. So these are the parameters from the first curve. These are the parameters for the second curve. So you see 5 values. What we want to do is create consecutive domains. So we have there is a component for consecutive domains. What it takes basically is a list of value, whatever domain of that is, and it will basically create a domain between the first and the second value, and then a domain from the second to the third value, and then from the third to fourth, etc. So let's go ahead like this. I'm just going to put a small panel here so that we quickly see. So yeah, we have 5 values and it creates 4 domains, which is normal because it's only the intervals of them, right? But as you can see, there is also something that is weird, is that it seems to like some sort of a partial addition as it goes. So if true here, values are added to a sum total. And that we don't want. We want the domains to be really created from the values, like always from one value and the next one, and then the next and the next one, etc. And so here we end up with the last domain that goes from 7, whatever, to 1. Okay. Okay, great. Let's do just for the first curve, and then you will see we'll just duplicate it for the second. What we have to do now, we have here all the parameters that are for the planes. Let me just disable these planes because we're only speaking about the ones on the first curve for now. So these parameters are evaluated from here down to there at the bottom, and it goes from 0 to 1. And so here we have 4 domains that go, the first domain goes from 0 to something, and then the last domain comes from 0 to, from something to 1. So we can just test here in which domain these values are falling into. So there is include domain, includes, and you have all the values that you can put here and all the domains here. Once again, here we have like a list of values, and here a list of domains. What you want to do is test all the values against like all the domains, like each one of the domains. So you want to graph this. So it will create like a lot more value. It will basically quadruple the number of values that you have. And this will be just the Boolean, as you can see here. There's a little logo for Boolean values, so it's true or not true. And so what we want to do with that is simply cull. We will use it to remove the planes that are not correct, like that should not be on a certain curve. Okay, so it will only keep the ones that are in a domain. So here we are connecting this like that. So okay, something here that might be a bit tricky to understand is that we are testing it against 4 branches of 101 values. And we are just testing that with 101 values. So it means that for each branch here, there are true values and false values. If you look, there are plenty of, like the first one actually will be true. That's interesting. Yeah, it's normal. And then it will be false values here. And then the next branch, so after 101, it will start with false because it means it's not in the first domain, it's in the second. So you have to go a little bit down and then it will become true. Yep. And then it will become false again because it means that it is not in the third domain. So here what we have now, I'm just gonna tree branch. So I'm running out of voice already. I'm just gonna select this here just to show you what because like this looks exactly the same as what we had before, but actually we have some branches now, and so let's just display it. Here we can see that you have the planes that are only on the red curve, right? And then if you select the next branch, you have the ones that are on the purple, then on the green, then on the orange one. So that is exactly what we wanted. So this is just because we tested against and then culled the one that are not on a specific curve. So we just pass that here, and yeah, let's just do the same here. So I need the second parameters. I need to include here with these two, right? Parameters of the points, number 2, and the domains. And then you wanna cull it here. I hate when there is duplicated code, but sometimes it's the most normal way to go, and it would be more of a nightmare to try to make it like it will be less understandable, you know, like less yeah. You can also always want the code to be visible, like understandable when you read it. And so right after this, now that we have planes into branches, remember we had also 4 vectors to move the curves up. You know, we had to move the curves up and away from the center, right? So I'm gonna just display these ones and these ones. I don't need that anymore. I'm just gonna remove that. And so we had, yeah, I was saying we had vectors here that we passed on into the variable train. Oh, that's a good name. And so here we have all the planes that are in different branches, and we have 4 branches for all the planes, and we have 4 branches with 1 vector for 4 branches. So what we just need to do here is quite obvious. It's just you take these newly branched plane and you move them with the vector, right? You do the same for the second ones here. Yes, it's already okay. And you pass the variable long to continue. And so now I'm just gonna, so that it's more clear. Yes, here we go. So now we have the planes that are placed like correctly on the the curves, right? So if you start here, I'll just show quickly. If you start messing around with the displacement of the curves, you'll see that it will follow, right? So we're moving the curves and moving the planes separately, but you can see that they are always matching. And you can also like decide to create, I don't know, 8 different curves, and you can see that all the planes are always going to be like matching the curves, like on which curve they should go to, okay? And the gravity seems to be also, you might want to recheck again gravity, but not for this. These values should be fine. If you change like more these values at the beginning, you might want to check again gravity. Anyway, I'm losing a little bit the point of this part. So now that we have this, if you remember from the PowerPoint, now we want to duplicate the whole thingy here, above and under, right? So to do so, it will be on this place, but what we need to do is create a bunch of vectors, this time only in the Z direction, because it will be only above, like in really 1 above, 1 under, or 2 above, 2 under, okay? So here in the completed version, I realized that like I did it in one way that is maybe not the easiest way to understand it. So yeah, this morning I went through it and I saw a different, maybe like an easier way to go, let's say. Okay, let's start. Let's say we want to have 3 times this piece. We want it 1 above, 1 where it is, and 1 under. So it means that we want to create a vector that will have some value, a Z value, right? This one, since we don't want it to move, it has a vector of 0, like a Z vector of length 0. And then 1 under that will have the same value as the one above, but negative Z value, right? Let's go ahead and start with a slider. We'll start with 3, and let's say we want it to go up to 9. So why 3 to 9? It's because we want actually the values here to be odd. You can select this odd number only. Why so? It's because we always want to duplicate above and under the same amount of time. Okay, and so there will always be like 1 above, 1 under. It makes 2, and then you add the one that is in the middle, so that makes 3. So, and then 2 above, 2 under, 4 plus 1, 5. So always odd numbers. So let's just start with 3. Okay, and you want to create a series out of it to have 3 vectors. We have the height here, which is the let me show you, which is basically the height of this initial curve that we created. I'm just gonna, don't mind me, I'm just switching off preview. So this is the height of this curve, like the end of it compared to, yeah. And we have also the maximum height value. So if you remember this, it's from, I'm just gonna show half a second here. It comes from, you remember when I explained this part, like we have a group here, and we need to have an additional here, an additional value to move from. That's where I'm gonna go back here. That's where we split it, a small list here of Z values. We extracted the maximum Z and the 4 values that we needed. So now it's the time to use the maximum value here, max Z value. So this is the same, it's just connected up to here, up to here. Okay, so how will I start this in a simple way? Okay, so we want the z factors, like for translating this, we want to duplicate above first, and then we want to duplicate it with a vector of 0 length, and then we want to duplicate it under. So we want to start at some height, and then have a step that will be negative so that we go down, all right? So the step, we have it already, is the maximum z value, right? We need the step to be negative, and we want, let's say, 3 value. So we have that already. So you'll see here that actually I made a small mistake, I'm sorry. The maximum z value is just the distance between this curve and the next one that will be above. But the complete value, we have to move from the bottom here to up there somewhere. We have to sum the total height of the curve plus the tiny little separation that we want. So we have first to sum them. I apologize for the mistake here. Okay, so we have now values here. If we create vectors out of this, z vectors, we will have a first vector of length 0, and then a vector that will point down with 54 something, and then a second one. That's not what we want to do. What we want is, let's say, for example, to start at the maximum height, okay, and then we go down by that same amount 3 times. Let's see what it looks like. So this looks already like what we want, right? We start at 54 something, so it will be something here, and then doesn't move, and then it goes down. Okay, but what if we want to duplicate more? If we want to have it duplicated twice above and twice under, then you can see that it mixes up a bit. Like we don't really have two positive values and then 0 and then 2 negative. We ended up with something like this, which is not correct. What we want to do is just increase the start value. We want to increase the start value by the half of this rounded to the value under. Let's just show and explain. So if you take this divided by 2, you end up with 2.5, right? You will end up with 2.5. What you want is the value to start by 2 times 54. So that you start at 109, and then you have 54, and then 0, and then minus 54, 54, minus 109, and then this one doesn't exist. So to do here, we want to round, and you round to the floor. So it means that it will try to round to the lowest number, lowest closer integer, and you want that to go. You don't want that to go there. You want to multiply this by this value, right? You want to start by 2 times 54. So 2 times, we just multiply this by that. And you connect that to the start. And so now you can see that we have 2 positive values, 2 negative values, all of them with the same like interval, the same step, but just like equally distributed against 0. And so if you go down here, you see that it's still equalized. Why? Because here it creates, so 3 divided by 2, 1.5. We take the floor value, and so it's 1. So we multiply 54 only by 1, and so it means we start at 54. And so now it applies to whatever odd value that you put. So it's important that this is odd values only, right? So this one. Okay, so this was a bit of a long speech for this one, but I think it's something that can be. So yeah, it's here it's a bit messy. I'm just gonna leave it like that. What you wanna do with this is ultimately create Z values, Z vectors in the Z direction. You connect that to this. And here what we, like you see, there is also another variable here that is awaiting. And it's actually this one. You want the complete value to be translated along. And this will become handy for total Z. It will be handy for the camera. Okay. Yes. It will be handy for if you want to add some camera movement that I didn't even posted animations with yet, but is quite interesting as well. It makes some. You will see. We will discuss that as we go. So the last group here. We want to basically move the curves, the ones that we have here. We want to duplicate them with the vectors that we just created, right? So to do so, let's take a move component. And what, so here we'll have like two curves, okay, every time, like the two reds together, then the two purple together, etc. And here we only have like a set of vectors. Here I have 9. Let me just fix this. Let's just go here. If for everyone, I think the best is to go with 3. It's easier to display stuff on the screen, and it's easier to explain, and it's also maybe a little bit faster for the computers. Okay, so we have 3 vectors, and we have like, let's say, group of curves. We have 2 curves into branches. So you want to move these curves up, like with these vectors, but you want to group these curves together so that you have one, basically one item per branch, so that all the item in the branch will be moved by all of the vectors here. If you do that, you can see that you have now all the curves above and under. Okay, I'm just gonna disable this. And I think there is also something else, no? Yes. And now you can see this appearing. Wait a second, what's further away? Okay, here. So we have this, they're moved. And now let's like translate here the variables. And here, so you can see here there's a variable that is called whole curve grouped and all curves. So here, basically what I want you to do is just ungroup the curve already. So this will be useful for further, but it will also allow us just right now to display here the curve with the right colors so that you can see what happened. So once you connected all of this like this, I'm just going to show for the ones that, if I went a bit too quick maybe. So here it's something that you have already. I'm just going to go through. It's only visualization again. You can just display this. And you can see, you will see that you have, all right, the curve duplicated above and under. And so this is the, like the height difference here is the maximum Z value that was maybe a bit less easy to understand. As you can see here, there is also, like, if you zoom a little bit, you see that there are tiny circles, okay? what I want you to do now, so it basically imitates this component. If I put this like activate this component like so here, it's heavy component to calculate, so that's why I don't do it. But basically here we have already some geometry, some pipe geometry, right? I'm just gonna leave it disabled, and so I use like a simple circle to see where the pipes are. And so what I want you to do for the ones that are doing the following along, I want you to go here in the properties tab, and just here go to parallel projection. So once you're in parallel projection, that is where, so the trick that we are doing now will only appear into parallel projection, okay? So basically in parallel projection, you don't have the impression of distance because there is no endpoints, perspective endpoints, if it's like that we say in English. Yeah, I don't know. Yeah, probably something like that, you know? So you can see all these lines of the planes are parallel, and so it actually looks odd when you look at it, maybe. And so look here, what happens if we align the camera into one specific direction? You can see that these two lines seems to be connected. And then, these two don't look connected, right? But if we align the camera differently, they are connected now, sort of, right? And so this is how we will we will orient the camera in the right direction when the glider goes through. One small detail that I will say now that will probably go again later is that you can watch from this direction, right? It appears to be connecting, but you can also watch from this direction. Okay. So actually in my first animations, like I think it's more than a year ago when I first did one version of this, I only stick to one direction. And for this one, I implemented something where you can change as well, so that there is bigger movements of the camera, and it will really create more interesting things as we go through. Okay, so this is what I wanted to say about this. All right, so we finished these blue groups. I'm just gonna turn off this. I don't know. Let's keep it on. Let's keep it on for now. Yes, let's keep it on. We're gonna dive into these light blue groups, which are the construction of the gliders and how to animate them. So now we're gonna start and see some moving stuff, because I believe right now some of you might be like, what? Like, why am I here? There's no animation and stuff, but it's gonna start happening now. I'm just gonna drink something quickly, and we're gonna dive into this again. So I'll be back in a second. All right, I almost forgot my microphone, but here we go. So here we create the gliders. So first we will position the plane that we, let me go back to this one. So we have the planes here that are on different curves right now, okay? And what we will do is put them also on the duplicated above and under, the curves that we just made in this very last part. And then we will be able, as I told you, just to select through them. And as you select the planes simply, and you can see that there is like some sort of animation that starts to appear. And you can see that there is this gravity effect just by having more points to select through as it goes to certain areas. right? So here, once again, there's a little like low number of points, and so that's why it looks like kind of you know, like low FPS going on. But if you just add more points, this is just a one value. We will do it together. You will have something that is completely smooth. So how we will create the gliders? So here there's something that I discovered with V-Ray is that like V-Ray V-Ray is specific for the U and V direction of any surfaces because it applies textures onto it, right? And so if like on a certain piece of geometry, if the geometry moves, you always want the U and V directions of every of its faces to always stay in the same directions, right? And so first of all, I was creating the gliders in place as we go down the animation here. We would create every time like circles and connect them and then create pipes out of them, right? Like to have this like this geometry basically, okay, but create it as we go here down. But the thing with that is that the pipe component, I believe, will create like sometimes the U and V direction of the created pipe will vary, will change based on the orientation of the planes and the direction of the points and stuff like that. So this is something that we want to avoid. And so what we're going to do is actually we're going to put the planes down here onto the, this is the origin of the model. So it's really the 0, 0 point. Okay. and from that, from these 2 points, these 2 planes, we will create the geometry. So this geometry will never move, right? I mean, it will, the planes will always be the same. You will see that there will be some movement, but it's not that important. And then we will move them back in place so that we are sure that the U and V of the surface here, the pipes, are always in the good direction, so that when we render an animation with V-Ray, we won't see any trouble. And that's it. That's all we're gonna do for this one. And then after that, it's the funny part of camera movement. All right. So first of all, we have to remember we have to move these planes that we have here. We have to move them again above. Basically, we have to move them here, so with a distance of 0, and then move them down. Okay, downward. To do so, we have already our vectors here that we created here in the messy 30th group. And we have our first planes. Sorry, I zoom out and in a bit too much maybe, that we have here. So first plane, the ones that are on the first group of curves and the one that are on the second group of curves. So once again, we want to move them. We want to move them along Z, these Z vectors that we created. But then, once again, like the curves here, we want to group them so that we move all the planes in one branch as one item, so that it will move against all these vectors. So the group, maybe if I show it like this, you will see that it creates, like, basically it moves the first point of the first branch, and then it will go into the second branch. And so this will never like position everything together. You want to move them, like you want to move the planes against all the vectors. So here I'm going to group. And now what we can see is that we have all the planes. These are still groups of planes, right? If I check here what it is, it's a group of planes. It's a group object, group with 38 objects, which is 38 planes. And then, yeah, okay. So I'm just gonna remove this. We wanna do the same here for these planes, right? And that's it. Here, all the first planes grouped. We can still give that. That's all we need. And here the same. You see the planes are moved, but they are still grouped. We want to give that here. I named it like so. And here, once again, I believe that it is for camera movement as well. Later, we can already like ungroup them and pass them here. We will need them for the camera a bit later. So ungroup simply all the planes. And so here it already creates like, yeah, we have a small data tree going on, which, for example, the first branch will tell us if we are on the red, the purple, the green, or the orange curve, the first data tree structure, the first number. And then the second number will tell you, so 0 would be in this group, 1 will be in this group, and 2 will be in this group. Okay, so this is not necessary, like not mandatory to understand, but for the ones that will stay and try to understand these two parts that we'll cover at the end, it will become yeah, it will become the center of the attention for that part a little bit. Okay, so we have all the planes in the right position. Now, basically what we want to do is start selecting through them. Okay, so we're gonna select, and from 0 to the n number of planes that they are in the lists. But to do so, first we have to like rearrange a little bit the planes, like rearrange the branch if you want. So for example, here so I'm just gonna quickly ungroup them just so you see. Don't do that now, maybe. So if I ungroup them, I have plenty of planes here, and if I just list item, you can see that I will be selecting, like at every different subcurves, I will select an item, and then as I will go down, I will select 2 items at every single curves. And that's not really something what we want. So we want to basically reduce the structure of the data tree so that the list of the planes are like basically contain, we want all these planes to be in one list, and all these planes to be in one list, and all these planes to be in one list. Like so in different branches. Yeah, branch number 0, branch number 1, branch number 2. So that when we select the first one here in this branch, and we go down, we will also select the first ones here, and also select the first ones here. That will make a lot of sense here, but I hope that this was clear enough. And so the structure that we want, I'm just gonna do it here. The ones that want, you can really try for yourself. We just basically we want to order them back to like having the branches that tells you which group are we in. And so here we have 3 branches, which corresponds to these groups. And now that we flipped, we want to ungroup the planes. Ungroup. What we have from that is still too many. You can see here it will not be what we wanted. But what we can do here is a simple shift, a path shift path, and you connect. There's a way to do it from this directly, but I think it's makes most sense to pass first for that structure. So what we have here now, it's 3 branches of 101 plane every time. So if I go list item now here, you will see that I select one plane here above on the red, and then no plane here, no plane, no plane, no plane. And then I go down here. Again, I go back on the red curve, but in the second group, right? In the second group, and you can see that we select the first plane. Okay, and once again on the red curve here on the last group, we select the first one. And so as we will go here, for example, let's say 0 to 10, no problem. 0 to 10, you'll see that we select these here, but we also select in the middle group, and we also select above, obviously, because it's in branches. Huh? So we connect these there, and once again, some lovely duplicated code. We just do this, and that is how we will do for that. So now in both we have 3 branches with the planes that we want. So let's start to see a bit how it moves. So sorry, I was reading a small message. So let's animate, like, see what it looks like when we go through all of these planes, right? So basically it's a list item, as we just saw here with a small list item that I used. I'm just gonna put this in the appropriate group, right? We're gonna want to select through through the first planes and through the second planes, right? So that we select the planes that are on one curve and the planes that are on the second curve. Okay, here we have 101 plane per branches. Okay, so basically what you want is, let's do a slider from 0 to 100 so that you have 101 value because you have 0 as well. Basically what you want is something like this, right? You want to, let me just display planes. Let's put 5. Better. So you have the planes here. And if you go to from 0 to 100, you see that you go, like you do the complete animation, right? Okay, that's great. But what if you have more planes? What if you decide to make the animation more smooth, like we said earlier? Then you will have maybe 200 or 500 planes, and then this slider will be obsolete. You will have to update it manually, which is something that I don't like. And that is not practical for any animation. For any animation, I really strongly suggest that you have here, this is something that is already prepared. Just look at this one. You want also always, to have a slider that goes from 0 to 1. And that has, let's say, the maximum of digits that you can have. Okay, so that if it wants to create 3 frames, it will create a frame here, it will create a frame here, it will create a frame there. Okay, if you want 4 frames, it will create a frame here. I mean, here, 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 5 frames, etc. So it doesn't. This doesn't. This doesn't, it doesn't care on how many frames that you want. It will always find the right value for that frame. Also, something that a good counter example is, for example, if you have, let's say, I don't know, 4, 3. Let's do. Imagine you have something like this, a value slider that goes from 0 to 10. If you want to create 4 frames, you will start here at 0. Okay, the last one will be 10, but then like you want to be at 3.333, right? And you can see that we cannot get it 3.333. So we will have to modify also the domain, etc. So it can be, sometimes it can skip a frame if you are not using, if you are using different domains and stuff. So I really always suggest you to go with a value from 0 to 1 with 6 digits, for example. And that's what we're gonna do. So it's actually something that we used here for the shift value down here. If you remember, we have the length of the list and we multiply it by 0 to 1. Okay, and this is exactly what we're gonna do here. We have a list of plane from 0 to 100. So we're just gonna do list length. And yeah, so this one or this one, I think I'm gonna take this one because it's closer to the thingy. Here we have 100 and inside it means we have 101, right? So it means that we have planes, yeah, from 0 to 100, and that's why we have 101 value. So 0 to 100. So we want to subtract 1 to this. We want to subtract 1. And then we multiply this by our slider that goes from 0 to 1. Okay, so this is this one. You can already, so this one you can delete it, and you can take this and put it here. And we're gonna check together what it means, what it creates. Okay. I'm just gonna duplicate this. Okay. So this is a good place to keep it. I place it here with a component that is for V-Ray. This is for creating animations with V-Ray. And this little story that may sound a bit meaningless about the value of the domain, the value of the slider that has to be between 0 and 1, actually even becomes really handy with a V-Ray timeline, because we have here something that is called the fraction, which is basically the same value as this one, but for V-Ray to know which frame it is. So at the end, when we render with V-Ray, we will simply move these to there, and that's it. We can go. We can send a V-Ray animation to the. Yeah, we can torture the computer with a V-Ray animation, let's say. So really, I would suggest that. So I duplicated this so that we can just move it around. So here I'm just gonna connect it right here. So now you can see if I go through from 0 to 1, I will select basically here, I will select the index 17. And so it will select the planes as we go through, right? And so I'm trying to move it like as a, let's same speed, but you can see there is a slowdown and then it accelerates again. And so let's test already, since we can, let's test the transitions, right? Let's see if we align here these two. So this is already for the next groups, but it's interesting to see. When we align here the curves together, so where the camera should look in the animation, if we go through, it looks not bad. Let me just increase a little bit. Maybe don't do it. I will increase the number of points. I will say 500. And then I go back just to scroll through here. Yeah. So we don't see that actually the curves are separated. And so that's where the illusion will be made, right? So bear in mind that the enemy to these kind of tricks are shadows and lights and reflections, right? So actually, if we just quickly go back here, if you look at this one, you can see when it jumps, there is some light changes of colors. Maybe at some points you can see, you have to be a little bit really looking, but you can see some stuff like being more bright or some changes in light a little bit. So that's always something to keep in mind if you start playing with renders with these kind of tricks. Okay, so we have our planes here. Yep. Do I want this to be here? Let's just connect the real animate slider so that we don't get lost now that we show. Okay, so now to move it, oh, screen is about to turn off. Okay, we have to move this one. Okay, so that we know where the animation is being made. And then we want to pass on the newly created geometries. So selected plane number 1, selected plane number 2. Here, just a quick way. I should have done that really while showing the. Oopla. Ellen. Just to show you what the gliders will look like, I'm just gonna create a custom line preview, and then I'm gonna put value of 10. So you don't really need to do this. It's in the completed definition. So basically here I'm creating just a line, just so that you see. I'm gonna move them where the gliders would be, but I think it was already quite obvious. We will see also, yeah, that's it for now. All right, let's go to the next one. Now what we want to do is to have these planes basically have these planes, but laying down here on the main plane, on the the main construction plane. All right. So first one, we know that, so this is for the U and V of the surfaces to be always in the same direction for V-Ray. So it's to be sure that the textures will not flip as the animation goes, right? So first of all, what I want to do is to orient first plane from this so some plane from, for example, the how to say, want to orient first a group of plane from the position of the second to the X and Y origin plane. Okay, we want to bring down the planes down to here relative to this one. So orient a component. I think in the, let me check, in the other one, in the completed version, yeah, let's do the same as this one. We want to move the second plane, so the planes that are on the second curves, these ones. This one, so the curve that goes around. We want to move these planes, and we want to move them from these planes down to the X and Y origin plane. You don't need to connect this one. It's the default value, but yeah, it's always good to, you see it doesn't change. So you can see that we have planes that have popped in here, right? And let me check something. Looks a bit odd here. No, it might be only, okay. So if I move now the animation, you will see that they are a little bit orienting itself, right? And it's because the glider is like sliding down, but it's also twisting a little bit, okay? But as you can see, like they always stay oriented to each other. So when you will create the pipe, it will always be, always correct, okay? So here we are. And then what we want to do basically is create, we want to have the same amount of X and Y plane than the amount of these. So here we have 3 planes basically. This one here we have 3 planes, and here we only have 1 for now. So we want to have longest list. So it's the easiest way to duplicate elements based on another list, right? Instead of use the duplicate component, for example. So now we have 3 planes, these ones still, and we have 3 planes on the X and Y thingy. We will group them, not group them, but like gather them together in one single data tree, and we will create circles, small circles up here. Okay, and so yeah, these will be the base for the gliders. So now, before we go towards here, we will start creating the connections, the connection pipe between the two. Okay, and so connection pipe between the two. We go down here. We have group 38, 39, 40, 41. And here, what we want to do is basically find the distance, the radius that we want for our circles here, right? Wait a second, I'm just checking something. That looks a bit odd. No, that's totally normal. Okay, my bad. Apologize for that. So we want here to find the exact dimension that we want for the circles, right? We could have here like just one slider, and you have to set it yourself, right? If it's only that, then you might have problems, for example, when you will increase the radius of these pipes, right? The rails, if you increase the radius of that, you will also have to increase your values here, which is something that is not optimal, like not the best way maybe to do. So we want to create the radius based on the radius of these rails. So this is already the value that we have. So right now, these tiny circles of the rails are 0.2. Okay, so you want to add 0.2 to something. And so let's say you want to have something that will go like so. Let's add a 2 so that we have. Let's say you have this, right? And this, you can use that. This will be, for example, the radius of the pipe that will go around this circle. Okay, so you have the pipe radius here, that is the radius of the rails. So it's more like rail radius, I should have called it. And And then here you have the ring radius, the ring pipe radius. And what we want also to add, it's something that might become obvious later, is like also a margin. So it will create space between the pipe of the ring and the pipe of the radius. So let's just duplicate this one so that we under, for example. And so you can connect like so. So here, let's call it, let's duplicate this. I'm just gonna call that like that. I should have kept these already made. And so here, this is ring margin. Right, so one will be the value for the pipe that will go around the rings, and the other one will be for the distance it has to clear the rails, basically. And so we will use these value here, 1.2, to set the radius of this circle. So I just pass here the values, and then we will just, probably we can already go back here to the 42. So I'm sorry, the numbers are not in the best way to explain, but let's go back to the 42 first. And let's simply create a pipe out of the first ring. So the first rings are, oh, sorry, apologize. Here we forgot to connect. So we just created the value of the ring radius. Let's connect this to the pipe. And so you can see the pipes are a bit bigger now, okay? And now let's just add the pipes for this pipe component. And we pipe this, right? So it's a bit too big, but here we have the ring pipe radius that we set earlier, okay? And so now we have our, so remember there are 3 of them, 3 there, 3 there. And so now we have our ring pipes with, based on this, like these pipes, the radius of these pipes, based on the radius of this ring plus a margin as well, okay? All right, and here, just before we pass this further on, we need to simplify a little bit the tree. So let's just use shift path component, and you want to actually shift it in the other direction. So here the index is minus, like the offset is -1, so that it shifts. Yeah, it shifts from the, like, how to say, the structure that is more to the right. So the outer structure is reduced, but what we want is to reduce the inner structure, so that we will be able to, so that we are back to this structure with like the 3 of them, and then in each branch we have 1 there and 1 there, 1 there and 1 there in each branch, so that we can put them back together, because this is how they came at first, right? They came with, from the position of the curve to here, with only one item per branch, if it makes sense. So we can send this further. Oh, I want to disable the preview there. Okay, so now that we have done the 42, so the ones that are following, let's go back here down and finish this. We have now to create a connection between the 2, right? And so, yeah, to do so here, group 39, if I'm not mistaken. Okay, so group 39 here is find the X coordinate, like basically we want to find here the length of the bar, right? So the length of the bar, if you look correctly, we want the bar to come from here, the end of this, the connecting, the bar that will connect the two pipes, two circles. We want it to start here at the edge, like here on the circle, and finish here on the circle. What is this distance? It's quite easy to imagine. It's the distance between these 2 points, right? Minus 2 times the radius, because we have one radius here and we have one radius here. So the informations are already here. Actually, this one you don't need. It's something that I simplified, so you can just delete it. We just have the second radius. So this is the second radius is the distance between the two, because it is how we created these curves, right? And then you have also the ring radius, which is the distance here. Like for this, the radius of these circles. So yeah, we need 2 times the radius. So you multiply this. Like so, and then you subtract that from the value above. Up, like that. You can pass it to the next variable here. And so here it will be like 7.6 will be the value, the length basically of the bar, the connecting bar, right? Let's now create the first point for the bar, and we will create also the vector to create the second point, and then create a line and then pipe the line. So basically, we want a point to be sitting here, right? We want the first point of the bar will be sitting here, right? So we want to construct a point, for example, construct point with, let's look, we want it on the X direction. This is the X axis, right? This red axis, and you want it to be with the radius of this circle. So we have our first point here, right? And then this will be our first, the start of the bar. And then what we want is we have, oh, here I think I made a small mistake. No, okay. And here we have the ring radius that will tell us the direction, and we want to have the x-axis again because we have to move the point in this direction, in the red direction. So let's take this, let's multiply it by this, and we have the x vector that we can pass along. And then once we hear it will maybe clarifies itself a little bit, we will create a line. This is the wrong one, I always get caught with that. We have a line here, and we will basically connect the first point of it, the beginning of the bar, and then we have to find here the second part of the bar. So we will move this point, right? We have direction and the length. So we just multiply these two together and move it like so. And as expected, I think there's a mistake as well then in the code here. So yeah, here I don't understand why I do this. Okay, this might be a bit of a small mistake that is quite stupid. So basically, sorry for that. I will like upload a fixed version of that on the Dropbox. Okay, so apparently here, I don't know why I created all of this. So let's just remove all of that. Basically, we want just a direction. So we know that we want to move the point on the X vector, right? On the X vector, and we have a length, which is the length of the bar, and that's it. We move it. We move the point in the direction with a certain length. And so we have the second point. We connected them, and we have a line, and then we create a pipe out of it. So yeah, I will send an updated version out of this, like from this. I wonder how it was working with that mistake though before. Yeah, happens, I guess. So let's add this, and then let's give the link pipe to the named variable. And yeah, we finished the link. So when we give this link back, it goes back here to the group number 33. So now it's the last group. And what we want is to position the gliders back into these orientations. Yeah, the orientations it was into before we moved them down. And so here, pretty straightforward. We'll just use orient again to orient the geometry from one plane to another plane, right? Let's move first the bars. So we have the bar here. And you want to move the bar from the X and Y plane, X and Y world plane. Yes, that's the word I was looking for earlier, the world plane, to selected planes here above, right? And then we will do the same here for the gliders there. Okay, so you might notice that these are working. Actually, everything is working. But here, let's just do something that, like for our case, it's working right now, but I will show you a small trick to make, to have like multiple sliders, like this one, for example. And so we need to graft basically here. Because right now we have only one plane one glider per branch, but we might have more. So here you want also to graft this. Yeah, so that's it. Now we just merge them together, and that's it. We have our geometry of the gliders in place, and we just give them like to the glider named variable, and that's it. Let's just see how it looks. Okay, I'll just disable some stuff, right? And I will also enable this so that it will be a bit more visible, maybe, right? So we have, I can move them here, and you can see that they are, yeah, basically nothing really crazy, right? But if you start moving, for example, if I go back here at the beginning, if I say, oh, the pipe radius, I want it to be 1, for example, okay? I just change it to 1. You can see that, oh yeah, it looks like really fat a bit, like more, takes more the screen, right? It's a bit, maybe a bit too much, I don't know. But you can see that the rings here, the gliders have adapted, right? They also went bigger. It's because we linked all of that here. We linked the ring radius to the pipe radius. And so here is the size of the pipe, right? And here is the clearance. See, if it's at 0, there is no clearance here. It's just a bug of display bug, right? And if you go up to there, there is 1 meter of margin. So this margin is actually really important for the transition. and we will see probably why later on. Okay, so that's it for this group. So yeah, I think the best now is to keep going and do these camera movements, and then we will do a break before making renders, like show how to make a scene in a V-Ray, like a really simple one, but still that will allow you to create some cool stuff. And we will see how to render both image and also animation, even though animation will take some time. So I will just show you how to do it, but maybe not do it on my computer, right? So let's just dive into it. Are you okay with going through the next group? I see one yes. Okay, let's go ahead then. We will have a small break as well when we arrive there. This should be, it might be a bit of a tricky part because we speak about camera movements and so stuff that we don't really usually think of. Like, I don't know, in architecture or whatever fields you're in. I mean, with Grasshopper, usually we don't really tackle the camera movements, right? Yeah, I think it's also quite interesting to see how we can sync the camera movement to the gliders going down. So let's go ahead. We'll just show this. So the next part is this one. Nope, I have to select the. Yeah. So we're here. So this is the last part that we will be coding together, and then we will go directly to that one. And cover the rest together, but reading. I'm repeating myself, I know, but just to make sure. So yeah, let's forget a bit the gliders for now, and let's go back, because the gliders basically for now doesn't really matter for the direction of the camera. Basically, when we were moving around the curves and the pipes, I showed you that if you aligned the camera to certain direction, the pipes appear to be connecting. So this is where we're going to start from. We're going to start from the pipes, and we're going to try to detect the connection of the pipes, and therefore we will be able to have the direction for the camera to point to. Okay. Since it's in parallel projection, the position of the camera itself doesn't really matter. It's just the direction of it that will be important, right? The position itself is irrelevant because of projection, the parallel projection. So we have here all the curves that we created earlier, all the rail curves, right? And what we want to do is just select the smallest part, the smallest group of them that we had earlier. So the group that is in the middle, for example. And yeah, we will find these lines, right? These lines are the connections between the curve. Okay. All right. So it means that when the glider will come down here and come right here at the end of this curve, the camera will have to be aligned to this direction. This or that one they are the same, right? So we can just take one of them. So the camera needs to be aligned to this, and then the glider will go from these two curves to these two curves, and then it will continue. Then the camera will have to orientate itself back to this curve, to these lines, these black lines. And then the glider will go, and then once again to these curves, right? Okay. But what happens when the curve go down here? If you remember correctly, if I go to the diapositive before, yeah, there is also something going on, like curves going downwards okay, that has been duplicated. At the same here applies above as well. We have also curves that come and the gliders will come from above and come here in these curves. So what we need to do is also select. So basically here, what I want to say is that we're missing one direction, right? We are only having 3 different connections, but it also have to connect it back to the beginning, right? So missing one connection. So to find that connection back, we have to just select one curve, one group of curve above, for example. I took above. It's just a arbitrary choice, maybe a bit easier to take. And here actually I've drawn also these lines. Okay, the exact same. These are pipes, basically, really lines and pipes. And I've created them here as well. But as you can see, we are like the camera is aligned in that direction. And so the curves appear to be touching when they are actually not touching. So this is already the glimpse of the illusion happening. So we will see exactly, we will turn around this geometry in a moment. I just want to say, we will basically have a position of the camera. Let's say this is something that is just to show you that this is the camera. It doesn't look actually like that, but it's just to say we will position the camera here. And then we will use all the lines, the black lines here. Okay, we will move them towards the center, towards the position of the camera, right? Here. And then from those curves here, of these lines here at the center, we will create a curve. Okay, and so this might look a bit like why? You might be wondering. Let's look in 3D what it looks like. So we have here all the 4 like directions that we have to align to, because there's 4 different curves, so 4 transitions to make, right? And so here you can see the curve that is created is basically the path that the target of the camera has to follow. So basically a camera in Grasshopper with the component, but basically the camera in Grasshopper, control the Rhino camera with Grasshopper is basically having 1 point for the camera, the position of the camera, and then 1 point for the target of the camera. So for example, here it's pointing towards that point, right? And so what we will do is just move that point along this curve. Okay. And that will, and you also need, for example, a Z direction of the camera so that you always stay like the Z direction always stays up, for example. You don't like twist the camera on the sides. And so we will move a point around this curve. And so if I go further here, what you can see is that, yeah, here these, basically I divided the, so the curve here of the path of the target of the camera, sorry, I'm repeating myself, it's a bit tricky, but I want it to be completely clear. You see 4 vectors here, right? These 4 vectors are created, like these are the same directions as the black pipes that I showed you before, okay? So we use these black pipes, only one of the pair every time, and we created vectors with them. And we also use these end of the vectors to divide the curve, divide the target path of the camera. And so, as you might be guessing it already, it means that when the gliders will be, for example, on the red curves, it means that the camera will be moving onto the red target curve, right? When the glider will come close to the, like will have to jump to the purple curves, for example, it means that the camera will have to be aligned between the red and the purple curve. So let's show that in action. So here you can see there's a glider going on. I hope this is fluid enough on the presentation, but you can see here that the camera aligning itself every time in between two colors when the glider has to go. Has to jump between these two colors, right? So here it will go between green and purple, up it jumps. Now it has to go with orange, up it jumps, right? And so that's basically what we're gonna do here. And then instead of rotating around like this, we will just use the center point as the position of the camera and use this moving point as the target of the camera, and that's it. That will make actually the illusion, like the movement of the camera plus the illusion already in one go, right? All right. I hope you're excited about this one. Let's first of all, I want to, because here I enabled this and I don't want that to be enabled. I will also go back here to a pipe radius of 0.2 because I prefer, simply. It's just a personal preference. And then let's jump back here. Okay, let's go ahead and do this. So okay, let's start off with some data trees that's really cool that you're excited for cameras. We have here all of our grouped curves. Sorry, I'm thinking as I go. If it's let's just stick to what I did. So what we want to do, remember, here we have basically, if I put a data component just to see what we have, that's a shame that these don't have any preview but yeah, let's display them. So I'm gonna turn off the gliders because we don't really need them right now. We just need the cameras basically. The rail curves, sorry. So we have the three groups of curves, 1, 2, and 3. These are the three items. So you can already see here that the structure is not oriented as we want. We want to have 3 branches of 4 group of curves, if that makes sense, because these are group of curves. So to correct that already, we will flip matrix right here. So now we have 3 branches of 4 group of curves, and we will ungroup them. Ungroup. Yeah, actually here I think I could have simplified a little bit this bit, but let's go ahead and just do like this. Otherwise, if there is a problem live, it's more tricky to fix. So to do so, now we have all these curves. I remember we just want to have the group in the middle, plus we want also to add, remember, 1 curve above, because we were missing a connection. We were missing a direction for the camera, right? So here I'm gonna use a component that is called split tree. So this is maybe something that you might be familiar to. I know I dived into it a bit late in my experience with Grasshopper, but it's a really handy component. Actually, I use it a lot now. So it allows you basically it asks for data tree, whatever it is in the data tree, and like a list of masks. So basically it's, if the values are in the mask, like if the masks are basically path, okay, so it will basically compare the path that you give here, and it will check if they are here. So you can see the data tree structure, that the part on the left, and it will check if the path that you give in the mask input are in the data tree structure. If yes, they will go here in the positive, and if no, they will go out in the negative. So you can take the positive and negative. So this is the main use of it, but there is also some stuff that you can say. You can say, for example, oh, I want to select, for example, if you say something like this, let's say 0, and then, for example, this, and you have to put it in the data tree structure like this in brackets, curly brackets. It means that, oh, I want only the branches that starts at 0 on the first index. Okay, so if there is a path here that starts at 1, we don't want it. We'll select only the ones that starts with 0, and then on the second index of the data tree, we want whatever you find. Okay, we have no idea what is inside. Whatever number that you find, you take it as a positive. So here, for example, it will select the 4 first branches, if you can see, because there is the 4 first starts with 0, and then that's it. And then on the right, there is 0, 1, 2, 3, and it falls into the whatever you want. So that is it. That's how it works, basically. So let's go ahead and work it out. So here we're going to analyze what we have, like what data tree do we have, and then we will create the mask out of it. So this tree statistic. So this group here is a little bit tricky now, because we will go, like, data tree stuff is always maybe a bit heavier to digest, like especially explaining it live like this is always a bit tricky, but after that it will speak more. We will create geometries and moving stuff. So first of all, here you can see that we have information about the data tree. We have all the paths that we don't really need, actually. We were interested in the number of items in each branches, and the count of the number of branches, basically. Right. So we're gonna use this item. We're gonna use. We only need one information that we have 3 items in the branches. Okay, so we just select item, select 1. And then this is a little bit of the same trick that we did quite a long time ago here in the apologize, here in the dirty 30th group. Is that we have a number, and to select the one in the middle, we basically divide by 2 and then round it to the floor value. And so we're gonna do here the same. We want to basically select all the path that starts with a 1, right? Does it make sense? Because if you look here, it will be the items that are basically the first number here tells you in which group it is, and then the second number tells you on which group of curves it is. Okay, so we want basically something like I showed before, but something like 1. Let's make like this, like 1, and then we want something. I switch keyboard. It's another layout, so I'm a bit confused. So basically, we want something like this, right? But we want this not handwritten like this. We want it to be dynamic. So if you want to duplicate more above and more under, you want it to be dynamic again. So you don't want to change this value manually. So here we have a value. We have 3. We know that we have duplicated 3 times. It's just a way to getting it back here. We divide this value by 2, like we did earlier on. Let's divide it by 2. Just gonna go a little bit faster on this, and then we're gonna round it now because we spoke about it already. So we will have here a value of 1. If we duplicate more, we will obviously have different values. And so here I'm just going to create like, I forgot how what's the name of this this sign, but it allows you to, yeah, concatenate like strings together. So strings is a piece of text, basically. And so here what we want to do is create like formats if you want the data like this. So there are other ways to format data. It's just something that is easy. So we would just want something like this at the beginning, right? And then we will want our value here, that is 1 in this case. And then at the end of it, we want something like this. I'm just going to zoom on it so that you see, okay, something like this. What this creates, so it creates, hey, what we needed, right? Basically here, if we go and duplicate more stuff above and under like this, you see there's more curves now. Here we will be selecting, I believe, number 2, yeah. So this one, you see, if you had it made manually, you would have to come here and update it for the camera to work properly. Yep, exactly, because it will basically create the camera here above, like even the position of the camera. So it means that all this geometry under will be too far and you will miss some geometry above. So yeah. All right, so these are, so now if you see, let's just connect this here. If I click now this, you can see that it only filtered the group that we want, the group that sits at this mask path, okay? So this is a really handy, tiny component. Let's go back here to 3 so that we keep this clean and easy to see rail structure. And so what I said also is that we want to select here the curve that is just right above. So this is a little bit more tricky to understand than this one simply. We will use the count here to basically we know that we have, also let's hide this, yeah. So we have, let's zoom here. Here we have a number of branches, it says 4, which means that we have 1 curve, 2 curves, 3 curves, 4 curves, 4 groups of curves every time. But this is not 1, 2, 3, and 4. This is 0, 1, 2, and 3. What we want to do is to select the 3rd curve from the group above, right? So the 3rd curve, index 3, from the curve above. So we're going to take one component like this again, and we're going to do like so. So we know that here, this is the index for the middle group. We said we want the group above. So this is like index 0, index 1, index 2, right? So here we have the index 1, and we know we want the minus. We want this minus 1, so that we will, like the first structure has to be one group above. This really, if you can play a little bit with it, this component, it will really be a great help, like for everyone, I believe, when you start really using data tree structures. And so here the index is 0. Okay, great. We want to connect this here. I'm just going to connect the panel so that you see what's being created as we go. So for now, nothing really fancy. And we want to also duplicate this tiny one, okay? So we know that our next selection that we want to add to these curves is in the group before and is the third curve with index 3. So index 3, we have to take it from here, which tells us the number of group of curves there is. So there is 4, and we know that it's just -1. So this is the same like when you measure a list of length of a list, basically to select the last item, you always have to do -1 because it doesn't account for the index 0. We did it a few times already. If it, yeah, here, like list item -1, and then we go through all of it. We did it also earlier on, but I'll just assume that it's clear. So we will do -1. So we have 3, and then this will be the second part of the mask. Okay, so yeah, what we can do basically is we can create here, like make it bigger, right? We need so this is a bit dirty way to create masks, huh? But it's just the easiest way, not to go through maybe components that are a bit more obscure. So let's connect them, and as you can see, it just misses one last tiny panel with this, and so yeah, this is what we need. So now we are only selecting one specific curve that is in the group, like in the big groups, at index 0. So it means in the first group, in the group here above, and then 3 is the last like paired group. So it's the last one, 0, 1, 2, 3, but above. So if I just select this, you can see that it selects only that one, right? So if I go here, I display all the curves, but I just with this mask, this one is the only one that is selected. So now what we want to do is merge the two masks together like so, and we connect. And now we have, see, the first group of curve, and then this one is the same as this one, but from another group, right? All right, this was a tricky one to do. Let's go ahead and give that to here. I'm just gonna disable that, and yeah, let's keep these curves. So after this, I don't know, maybe some of you have, what we want to do is renumber the data tree. Some of you might have this, some of you might not. I don't know if it's native. I think it comes from TreeSlot. If you don't have it, it's not a big problem. We can like do it with native component quite easily. So what it means, renaming data tree structure, basically, it means that let's I'm gonna make parv. Oh, this is not the correct one. Param viewer. So this will allow you to see the path of the data trees and what's inside of them, right? The number of items inside of them. So as you can see here, the data tree structure is like, this is for the groups, and this is for which paired curve that we selected in. So that's exactly matching the masks that we gave earlier. But it's a bit of an ugly structure, and that's not really what we want, since we will be treating them as like the first one, the second one, third one, fourth and fifth one. We don't really need to have this kind of weird structure. So we want to do is have basically 0, 1, 2, 3, 4. Okay, it's just one structure. And so to do so, with native components, you go with tree statistics, and then tree branch. And basically you select, I don't know if there might be a better way. Basically here it gives you all the path, and here you're basically selecting all selecting in the data tree with all the path of that data tree. Okay, but here it's not yet renumbered, but here there is a handy little right-click button that allows you to unclick this. And so if it doesn't maintain the path, it will renumber them. And so as you can see now, we have a structure that is way easier to work with. Actually, now we can just tree branch and select to that tree really easily, as before it was more more tricky. So now you can see we can select through all of them, right? All right. So this is only what this group was made intended for. And so now we're gonna create what like the lines that connect the rails. Okay, so these are here, here, and then here, and then down here, right? So yes, let's just so we're gonna basically find the endpoints of these curves. So there is a component that is called endpoints. We're just not gonna use that because we want them to be in the same how to say that, input. Like we don't want the start point and the end point to be separated. We want them in the same list. So let's do, so the other way to do that is to evaluate the curve, basically. Yeah, we have that reparameterized if it's not already, and we want to select the parameter at value 0, which will be the start, and 1, which will be the end of the curve. And so we will just create a small panel here that will be 0 and 1. You put the two values and then you right click and uncheck this multi-line data because you want only one data per row, right? You connect that here. And something that is wrong here, you might see, is that some of them have their starting point, some of them don't have, and then some of them don't have their endpoints, and some of them have. And that's basically just what I was looking before, and I thought I made a mistake, but I didn't. It's just here we have to, again, graph this value so that each and every curve is tested like at parameters 0 and 1, evaluated at parameters 0 and 1. And so now we have all the curves. We just have a slightly more complicated data tree structure, but that's really actually becoming handy right now, because we can use this data tree structure just to select the endpoint of this curve and connect them to the starting point of this curve, and then select the endpoint of this curve here and connect them to this one. So that's what we're gonna do. We're gonna use the relative item here, this one. We connect the data tree here. And so what we want to do basically is for each points that is here in the structure, in the data tree structure, we want to select one from the group, one from the, how to say that? Yeah, so we have a group of curve here, a group of curve here, a group of curve here. We want to select for each and every point, we want to select one group under, and then in the list, you always have the start point and the end point. And you want to select, basically, if you selected the starting point, you want to select the end point to connect. If you select, the end point, you want to connect to the starting point. So here, we're just gonna make here some path here. It will always be the same on this one. And so I'm just gonna explain it again. Sorry, it's the new layout of my keyboard. So basically, this is basically taking every point in the data tree structure and checking what's the relative other point in the structure with an offset in the path like this. So it means that if it tests for the path 0, 0, then for that point in that path, it will go 1 above. So here we can even write +1 if you want. Some people write it like that, I believe. So it means plus, I will try to find for you here. This component says, I will try to find for you the corresponding point that is +1 on the first path index. On the second path index, I will keep the same. And then in the list, I will take the one before, for example. And it does that for every single point in the list. And so if we look now, we see that it doesn't select the first point, no, and not the last ones, but all of the ones in the middle are selected, okay. But we can actually match them. Now we see that their organization allows us to get the connections between the two. If you change the values here, it will not work, obviously. If you change, for example, if you say, oh, I want to only change the group, it will, so only the different groups here, and the first structure is only the different groups. It starts with the start at each curve, and then it connects it to the start of the next curve, and then to the start of the next curve. And then the same, if it starts at the end of the curve, it will connect it to the end of the other curves, etc. So here, that's why we want to actually -1 or +1 should be the exact same. Why it is not? Yes, maybe. Okay. Let's just say that I thought it through back then. You can always, a good way to do is a text tag. Something that I'll do a lot is when you have points like this, it's really easy to just display the path of the, tree statistics. It's really easy. If you graph this, you can display the path of the points on their location, and so you can more easily see what are the connections that you need and what are the offsets that you need to do, right? So yeah, and basically here, what we also do, it would be to graph these, and so that you have the complete structure even in the list, right? And so we see that the first index has to always change here. We have to go from, can I do it larger? Yes, I can. The first structure has to go from 1 value to +1 value. The middle one doesn't need to change, huh? And the last one has to go from 1 value to -1 value. And you can see this pattern repeating as you go. So you go here, first value has to go 1 up, the one in the middle doesn't have to change, and then the last one has to go 1 down. And so basically that's how you can, I should maybe have explained this way first. This is a really handy trick. You might want to do that on personal project as well. Maybe you do it already. And yeah, that's it. We have our curves here, which the structure is a bit too much for us. We just actually need, remember, we have 2 of them. We just need 1 of them every time because it's just 1 direction that we need. So let's just simplify a bit the structure. We only need 1 curve. And so here, list item, and we select only 1 of them. Doesn't really matter which one. So anyway, it will always select the same. And we connect them. All right, so now we have these lines that will help us orient the camera. Okay, I believe this group is not that much important. It's just allowing us to, we can maybe come back to this one a little bit later. It's just when I told you that the illusion works from one direction, but it also works for another direction, like the opposite direction, basically. Up. You can see from here that these curves are also connecting, right? And so in this group, basically on the completed version, I will show you, which is this one, I believe. Yes. I forgot to put the numbers in the completed version. But this is, so basically we are randomly flipping the direction, the direction of the line. Okay, so here we use a flip curve component to reverse the direction, the line. So the end point becomes the starting point and the start point becomes the end. And we do that randomly. Here we pick and choose based on some random. So here you see that we had 4 different camera orientations. And here you'll see that the first one is not reversed, and then the 2 ones are reversed, and then the last one is not reversed. So maybe that's something that we will do later. Let's just for now connect these 2 together, right? All right. 48. In 48, basically, this is where we define the position of the camera. And then we will also create the vectors that we will be pointing towards. So here we have the camera directions. We will get the start and ending points of them, right? And then here, I'm just gonna to position the camera. I told you that the position of the camera is not really relevant. So I'm just gonna average the points. The starting points, for example, I'm gonna average them. And so it creates 1 point here, roughly in the middle. So that seems right, okay? And so 1 camera, yes, but we want also this camera. Still, I think it's better to be, so as you can see where it's here, but we want this point to be on the z-axis, to be like complete sure it's in the center of the geometry of the curve of the rails and everything. So I deconstruct the point and I simply construct a new point. I don't know what I was writing. With simply the z coordinates, and that's it. That's the point where the camera will be. So it's at the same height at this one, but at a better location for the camera, like in the center. We can pass this on. And here under, we will basically create vectors. So we have the starting points and endpoints of all these lines. And so we will create vectors with 2 points. So I'm accelerating a little bit because I see that I think in theory we have to finish in 10 minutes, which we will not do. But I had the green lights to go over the line. So if it's okay for you. Anyway, for those who cannot make it like to the end, the video I believe will be available. And as I said earlier, I'm also available for any questions afterwards. So really, don't hesitate to send me if you need more precisions on some parts, right? So here we will connect them like so. We just have vectors. Just to show you quickly, here we have starting point of the vector and we have the vectors, right? So we have here 4 vectors. I'm just gonna remove that. Let's go to the next. And here we will create the curve that the target curve of the camera, right? The curve where the target of the camera will be moving around, and yeah, basically on the curve, target curve here. So first we have to find the 4 points where the camera has to stop, right? So we have the center of the camera and we have 4 vectors here, which is absolutely perfect. We want to move the camera with these 4 vectors that we had at the beginning, right? And so we have here 4 points that are made from the vectors that we had. And so after that, we just interpolate to go interpolate this one. And we can go through. Yes, okay, it's not happy, it's normal. We want it to be a list. Yeah. And as you can see right now, it's not connecting to anything, right? It's just an open curve. And it's because here on the periodic Boolean, you want to invert it to true, so that it's going like so. After that, we want to like explode this curve. We want to shatter this curve. Shatter. But to do so, here, always we parameterize again. But to shatter it, we need some parameters, right? To know exactly where the points, like what parameters are the point. And so we've been doing that a few times already. We will do curve closest point. We will have the points that we have here at the beginning. We have the curve, and then, so basically here it creates the same points, right? They are like almost exactly at the same position. It's really a matter of tolerances, but way too low for us to care. And we use these parameters that go from 0 to 76 for some, yeah. And that's it. We use that, and we have now 4 curves. So if I select, just to show you, to be sure, we have like they are separated like this. Okay. All right. So we pass this on, and now we have to. Okay. So now we have to basically. So as for the glider, to animate the glider, we went like selecting a bunch of points one after the other. We will have to do the same here for the camera target. We will have to have a bunch of points on each segment and then select through all of them as the animation goes, right? Okay. I hope that makes sense. I hope. So first of all, here we see that I brought the planes here, all the planes, and it's to basically create, like if you have, I don't know, 50 planes here for the glider to go through, it means that you need 50 points here for the camera to move from one point to another, right? As like, yeah. And then if the next curve has, I don't know, 30 planes to go through, it means that the second curve of the camera target has to have 30 points to select one after the other, to orient the camera in the right direction. So here I'm just gonna use this plane structure. I'm just gonna lower it to the number of, so here we have 4, let me disable this. We have 4 segments, like 4 subcurves, 1, 2, 3, and then 4. It's a, and yeah, here basically we have, don't look at the first curve, we have 1, 2, sorry, I missed 1 here. Of 1 here, and then a small 1 here, and then 3, and then 4. Okay, so this is exactly the same structure, and here we have our 4 curves that we will divide. So I'm just gonna use divide component first, divide curve, and I'm just gonna do it like so for now. So I believe that here we have 4 branches, and so we want these curves to be in branches as well. Let's do it here in the group before, because, yep, because we can actually simplify it as well so that the structure is easier to read. Because we will also need that later on, so it's easier there. And let's say I'm just gonna list length. And we're just gonna divide, like create a bunch of points here onto these curves. Let me just change one value because I think I did change something earlier on. Remember here when we created acceleration, I told you to start with 100. So this makes it like easier to see now. So remember, this is the basically the number of frames that you can do in your animation. Because it's the number of, the number of elements that will be selected one after the other. So apologize, we go back here, group 50. Okay, so what you can see now is that the camera will basically select through these points, okay? Something that might, okay, so can I actually maybe, yeah. Like I should maybe show a quick example, but I don't know if we have time for that. Yeah, we will probably go 1 hour longer anyway. So all right. Can I do it? Can I show it here? Can I have, yes. So bear with me here. I'm just gonna show you something and then we're gonna continue on. Something that really will, like it's better to show a mistake and then to explain, you know, before explaining why we do something. So let's call from Heteroptera again. It's not that one. When you have too much, it's unreadable. Here, yes. I think it's in utilities, I believe. You have camera crane component. And so this will allow us to play with the camera. It allows us to set one point of the camera, which we can just really select like so, like really in a dirty way. Okay. I will remove it after. Actually, you might not even need to. And here I'm just gonna do a list item. Yes, I'm gonna so these are my points, the target points. Okay, I'm just gonna flatten all of them so that we will go through all of them as the animation go. And then I want to, so sorry, it will look really dirty. We will make something really clean afterward. You will understand. So basically here what I'm doing is, oh, it's not animate points. Here I want list length. I hate to do live, like it's not easy when you improvise. Yeah, we want basically -1, but we don't care. And so here we're gonna select through our points. So we're just gonna select 1 point. And so we have 1 target, okay? I'm gonna also display the gliders, and then I'm gonna go through the animation. As you can see, the camera is already moving, right? But what's happening? I'm gonna display these. So we have our pipes now that are being created. I'm just gonna do flat, even though we don't really see it. And I'm gonna remove this from site, yeah. And maybe I can select the target so that we can see that it's, we will see actually it moving. So what's happening now is that when we animate, we are already aligning ourselves to the correct direction. But you can see is that like first the camera doesn't really stop to the position, right? It just goes at the right time. So it's just something that can be desired for an animation. But as you can also see, like the speed is also different, see, between the 2 transitions. Like this one is slow. And then when you pass there, it will go fast because it has to go quickly the other way around. Like there's less point to go to, right? And so that's something that we don't really want, is like a change of speed in the camera. So actually we can have different speeds in the camera, but we don't want to see like a bump into the change of speed. Like the acceleration has to be smooth. Okay, so what we will do is we will remap the parameters value here with a graph mapper that will have a smooth curve. So one way to see that is basically just a quick graph again, quick graph also, quick graph, quickly a quick graph. So, oh, that's funny. Okay, yes. And then we bring our graph mapper, speaking and typing, graph mapper, yep. We will connect these values and have, so I tend to use either this one, the Bezier, simple Bezier curve. You can tweak a little bit the acceleration like so, right? But the one that I've been using for this animation is a segment curve. So basically it means that as the values go from 0 to 1, you can see that here the new value that will be attributed will be first like 0, 0, almost 0, almost 0, and then it will move up, and then it will be almost 1, 1, 1, 1, 1. And so we will use this instead to evaluate the target curves. Let me show you, like a demonstration will be better. Evaluate curve. And so now you can use these new parameters value that went through the graph. If you see this, yeah, it doesn't really show. I don't know why I did it. I don't know why I wanted to show you that. But here, here is something that I told you to do before, is to always reparameterize the curve. So here we had values that were almost linear. So the division along the curve was almost linear, right? And what we want to do is to really have something that starts flat almost and goes up. So the camera will not move, like the target point will not move, and then we will move it along. So basically we will have more points towards the beginning of this camera curve, all of them, more at the beginning and more at the end, and less point in the middle, so that it will go faster in the middle and will stop at the end. And it will be almost at rest at the beginning of the curve again, and then it will go fast, and then will be slow down again after, right? So yeah, this is something like that, and we have the target curves, and we need also to reparameterize this. And so now you might see it like from this, where it looks like the same divisions everywhere, like it's more tight here, it means that it will go slower. Here it's more separated, it means it will go faster, but you can see that the distribution is the same, like the same intervals, right? As of this one, you can see that we are starting at this point, it goes slow, and then it goes fast, and then it goes slow again. The camera is almost stopping. There is the transition happening, like the jump of the glider, and then the camera starts moving again, and it will go. If right now I connect here in my tiny little setup here, if I zoom out a little bit and I do the animation again, don't worry, we will do the camera properly right after. You'll see that the camera doesn't move right now. See, it almost doesn't move, and then it starts moving up, it aligns itself, stops, and then goes. You can also follow here the like the plane here is that you can see that we basically select through the points, right? We select that point, then we select the next one, we select the next one. This is how the camera works. And then here up, it will go to the next one. And that's it. So in an animation here, you see that, for example, this kind of frame is probably not really something that you will want, because it means that you will see that there is no geometry above and under. That's really something that you just have to like change a little bit the values and stuff. And so that the curve here will not be going directly under the camera, under the view, right? If you have a curve that will more turn around like this, you will not have the problem of flipping the geometry like this when it changes the position of the camera, the direction of the camera. Yeah, I'm sorry to extend a little bit, but yeah, all the files will be there, and really, if you have any questions, don't hesitate. Let's go ahead and finish this this tiny one. So what do we do in the 51? Yeah, that was basically what I did. I'll just list item, make it more clear for everyone to follow. We will have a list item. We will. Oh, here I forgot to pass on the points, right? We have to pass the points for the next group. And here you will have the selected target. You can already pass it. Here in the middle, we want to have list length. We can, apologize, here in the group before, we can flatten the points because we want to select through all of them, not one in each branch, right? We want to select all of them. So you have the list length, and then as we did earlier, when we select with a value from 0 to 1, which will be our animate value, right? It will be the same slider that animates the glider. We want to do -1, so that when we arrive at 1, we don't select the first item, if that makes sense. And here we want to multiply animation slider value by this. And so we will select like like the value here will be rounded by this component. So it will select like, so this is basically, this is our camera position, and this is our target camera for the position of that, for the current position of the glider. So the group 52 is once again something that I added that I didn't use yet in my animations, but is really like kind of cool, I think, is that we're just not gonna cover it. I'm just gonna show it here. This allows you to here. So again, these components with blue groups like this means that you can tweak it. We can change the things inside. And so there is a small note here that explains what it does. Basically, it has the option to moving the camera and the target up and down. So it means that if the camera is at rest here, if we don't move the camera, we saw that the gliders will go from top to bottom on the screen. They will always go from top to bottom, right? If you select to go down here, it means that you will follow the glider. As it goes down, you will basically move down the target and the camera with the total height of our curves that we had established before. Okay, so the glider will appear to be following the camera. Maybe I could actually show it here quickly. So if I animate, you can see that the camera goes down with the gliders, right? And if you select the other option, so for this you +1, it means that the camera will actually go up one complete block of curve as the animation goes. So it means that simply the gliders will appear to go way faster down, you know, because you go up as the animation goes. So that's just a tiny little option. I don't think we need to go through it because we're just gonna make the camera and take a short break and then do render with V-Ray. And for the ones that are still motivated after, we can cover these parts all together. Apologize, I thought we would have time to make it. Yeah, that's not really a mandatory part. It's really just to add some decorations, and it's maybe more advanced a little bit. So yeah, we just go back here. And so here I will just ask you to connect these two, which is camera and target, and final camera and final target, because here we would have moved them around with the animation. And here we're just gonna call camera crane again from Heteroptera camera crane. And we have camera, position of the camera. So you can see it's already moving actually. And we have target, right? And then we will also ask for a Z vector here. Let's let the up vector of the camera will always be the Z value. So that's something. And you want to add not a button, but Boolean toggle, I don't know, toggle, to be able to disable or enable the camera. So you see here, I can move around. If I, like now it's not refreshing. If I animate the slider here, like the glider will move, but the camera will not align itself. And if you double click, now it's aligning itself and it's orientating itself to the right directions. Yeah. So once again, here you see like there's this ugly little transition there. I don't know, we can just, hey, why not do 5 curves? Let's look at the, yeah, it should be a bit better. So now let's zoom out a little bit and see what the animation looks like. So now we have 5 curves, so it has to go through 5 curves. But you can see that everything else is working still, like the animation, the camera transitioning. Yeah, and so you see that the gliders also always stay to the right of the sculpture of the rails, always on the right part of it, and this has to do with the group 47 that we skipped, that is in the completed version, which allows you to switch the camera positions. So sometimes actually the camera, instead of going here, it will go right there. And so as you can see, the glider here on this image is on the left. So it will add, so this group will add a lot of like dynamic in the camera movement. Yep. So that's just something that so yeah, I believe this is it for this group. So let's see. Let me check first my definition here. So yeah. So I think I will not cover sorry, I was lost because I was reading also the discussion in the chat. So now we're gonna take a short break because I really believe everyone needs one. And then we're gonna cover here what's inside of what we need inside of these to create some images, and then I will also tell you how to do an animation. Yes, basically like that. I will also refer you to a small plugin that I like co-developed with Mark Differding. You might know him a little bit from the forums if you are on the forums sometimes. Like we developed a plugin that basically allows you to, so when you animate something with Grasshopper, basically it creates a bunch of animations. So yeah, there is a recording. Don't worry, there is. Is joking, is messing around with us. So basically, when you animate with Grasshopper, right, it's the right-click animation. You right-click a slider and you can animate it, right? And so then it will go somewhere on your computer and you will ask for a number of images that you want. You click OK, and it will start creating 400 images going from 0 to 1. It will create 400 different steps and capture the image of this, right? So basically the small plugin that I co-developed allows you to then grab all these images from Grasshopper, yeah, from inside of Grasshopper, and it will create like a GIF or MP4 video or other different formats. You can also like convert GIFs to videos, convert videos to GIFs. You can loop them around how many times you want. For example, when I do looped animations, sometimes the video is only 3 seconds long. And something that is weird is that Instagram doesn't like these small videos, like video that are this small. And so what I do is I render only the minimum videos, the minimum images, and then with the little plugin, I ask for like to loop the video 3 times, for example, and then so it creates a video that is 9 seconds long, and it's completely looped. So I will also refer you to it, but I will not go through the whole installation of it because it's a bit trickier. I made a small tutorial on YouTube where it explains for Mac and PC how to install it. Okay. So that's it. I'm gonna leave you for a short break. Let's say at 30. At 30, we have to go again. Yep. All right. Sounds good. I believe yes. Let's meet at 30. Great. What's this? Okay, so are we ready to continue for the last stretch? For the most motivated of you. All right. So yeah, we're gonna dive in right into these V-Ray components since we have basically what we need. We have the curves for the rails, and we have also the gliders. So basically, we can already have an animation out of it. And so afterwards, we will. So afterwards, like for the ones that want, we can cover all of this like with a finished, the completed version that you have on the Dropbox. All right, so I'm gonna turn off this camera. Again, I'm just gonna show the PowerPoint even if there is no much point of doing so, but let's go. I'm just gonna show directly the black parts and then we come back to the other ones. So let's pretend we are here at the end. So here we simply gather the curves, like I said. We create pipes out of the geometries. So as you can see here, they are the columns, like what I call the columns in the definition. So this is the part that we will not code all together, but are in the completed version. And so that's what I was explaining, that we will go through it, like go over it and display some stuff, but not actually coding it. I don't think it really is like a problem. I mean, I would have wanted to go through. It's just a matter of time, and like doing these animations is quite long, as you can see. For me to come up to those animations, sometimes it takes me a few days just to plan and go over it. So yeah, we're just gonna go through it, and if you have any questions, again, just ask me. And so in the end, we will just like create a basic animation with Grasshopper itself, and then we will also render it now with V-Ray. And so this is what you have if you didn't change any values, I think in your definition, I think you will have something like this. But you can also, like all of my animations, that this series of animations that I've made, basically any of these you can make as well. So this is a different type of columns. As you can see, they go in diagonal, these ones. So it's just like you could even modify a little bit how we create the columns and have different variations of it. This is another one, which is actually, you could do this one with the code that you received. So basically we are moving, you can see that one part of the glides of the curves are on the right, the other part is on the left, divided only in two directions, but you can see that they separated a long way, and then you have big columns that comes and grab them. So yeah, let's go ahead and create a small animation. All right, so just trying to be recording. Yes, they will be recording of the complete webinar on the website. Don't worry. So let's go ahead and let's simply select everything. I will select everything here and disable the preview. And I will ask you to pass here into rendered viewport. So as you can see here, there are geometries showing up. This is because the Rhino rendered viewport is basically any geometry that is enabled will actually display. So if I turn this off, it will disappear, right? So the lines here doesn't apply to the lines, but for example, no, that's it. In this definition, that's it. And so you see here that the gliders are already colored. It's because, so I come back here. It's because here you see that the gliders come here and then they come here and here they are. There is a preview, custom preview. So the preview is, if it's enabled, it's displaying on the rendered viewport. This component is just something that I found on the forum one day. It allows you basically to have some kind of reflection based on the direction that you are looking this shape from, and it has also like some kind of a smoothness, like a small texture when it's not brushed, but yeah. So the reflections as well, you can have less reflections or a lot of reflections and stuff like that. So this is really, I used to do actually my first animations with these kind of technique, and then I switched to V-Ray. So in group 69 here, we will just create, so we have the curves that are the rails, right? And we want just to create a radius, a pipe out of it. So let's just do that. Like nothing crazy. We have a pipe radius. We just use that as well. And so you can see here that we have tiny pipes like that. We can just make them flat, so that it means that they will have a cap here at the end. And we connect that to columns. You can turn this off now. And as you can see, you have already a nice preview because it comes here above, and we have also a different materials with a different, different color, different reflections and stuff like that. So this is if you want to render with Grasshopper. What we might do here, because since we don't have all the columns and stuff, I'm going back here at the pipe radius. So this is the variable for the rails. Huh? I should have said the radius of the rails or something like that, but I don't know. Let's put the maybe 1. Well, I don't know. Let's keep it let's keep it like so. Sorry, it's being a bit late for me. I don't know what I'm doing. I mean, I don't know what I want to do. So first of all, is there anyone that wants to see really how to create an animation with Grasshopper only? All of you know how to do. So it's the thingy with the right click on the slider. Want to see? Okay, I'm gonna, if someone want to see, I will just cover it right now. So I'm just gonna create on my desktop here, my dirty desktop. I'm gonna just create a file, a folder, and inside I'm just gonna call it here. I'm just gonna call it all images, right? Images, all images. And so here, as we see, like the animation is happening, right? The animation is working. So you have to decide, since we are in a parallel projection, you have to decide at which distance you are. You have to zoom it with this, and then when you find that the proportions are good, you can come over to the slider that controls the animations, basically. Okay, so this is the ones that we've decided to render animation through it, right? So it goes from 0 to 1, and we say, okay, we want to create 100 frames for example. Okay, so you right click on it, you click animate. It will have, can I make it bigger? I can maybe make it a bit bigger. So basically you have this, window coming up, and it will ask you where you want to save it. So here I'm just going to go back to my desktop. This is French, all images, and then you select OK. So now it will save all the images, all the frames in the images. You will see here that it will tell you like how it will number the frames, so that they will have a sequence number. They will be basically numbered so that it's easier to know which one is the first, which one is the last. What you want to do here is the resolution. Usually it's better to click on this maybe. I mean, so that it matches exactly what you have here on your viewport, right? And so now you can see that, yeah, we have this, right? And so if you want to make a resolution that is a square, for example, you take the one or the other. I usually take the smaller one, even if it makes a smaller, like a lower quality, and you put it on the left, right? And so you can see now that we have a squared image. The image will be a square one. And here you say the frame count. Okay, we said we want 100 frame, like so, and you simply click OK. And when you click OK, you can see that it will, the slider here moves itself, and you see it finds like what is the perfect value it has to save the frame. And you can see here above, it records, like it takes screens every time and it saves it to there. And it even tells you roughly how many times it needs. And so that's it. It saved all of it. So here the animation, like I made the animation, I mean, it's not really a computer heavy animation. Like we're just basically creating 3 or 4 pipes and just like orientating the camera along few points, but that's really quick and really fast. So that's why it goes really quick. If you, yeah, you can have some really heavy stuff going on, and sometimes animations, like I had animations like these, where I actually run out of memory of my computer, like RAM memory, VRAM. So yeah, so sometimes it can be really heavy. So it took like few, how many was it? I think I set it before sleeping, and when I woke up, my computer had crashed like 2 hours ago or something. So it was, it can be really, really tricky. So now we only have frames. Let's go back here and see, is this one? No, let's go back to desktop and in all images folder, and you can see that you have all your images here. So if you select one, I'm just gonna up, and then I go to the next one with the arrow keys, you can see that we have some sort of animation going on, okay? Okay, so there are different ways to create these. Usually people, so now we have to create the animations. So the timeline, I will do it right after. So right now I was just right clicking on this, on the slider here, right click, animate. Yes, so this basically is some sort of timeline. You're right, but actually this one is the V-Ray timeline. This is the other component that we will cover for animation with V-Ray right after. So here we just made animation with the rendered viewport of Rhino, so without V-Ray at all, okay? So yes, I was saying you have a bunch of images, right here. So people usually like create a video out of these images using either Photoshop. I believe there is a way to do it with After Effects. I think also with Adobe Premiere, I think. But you could also go to, I believe it's as GIF. sgif.com, and I think you can create GIF maker, and so it will ask you for images. Oh, hi. You go here in your folder, and then you select all of them. And I think there is a limit. Yeah, there is a limit up to 200 2000, sorry. And there is also a size that you can then upload and make a GIF. Did it work? Why is it not working? Oh, it's working. My bad. So it sees, yeah. And so this is quite like, it's not really handy. Like it's not something that I really like. If for some people it might be good enough. There is also here you can set the delay of each frame, and you can also add a number of loop if you want a loop to be like, for example, a GIF, it will loop indefinitely, right? Forever. So if you leave it empty, it will loop forever, but you can also put a number so that it stops at some point. You can also add some effect, and then you create GIF and you will have your GIF, right? You can simply download it after. It's a free website. You can do plenty of stuff, even other. Sometimes I use it because sometimes the small plugin that we created that doesn't have the option that that website has. The other way of doing it, I'm really quickly showing it. I'm not gonna cover how to install it, but I'm gonna link, actually I'm gonna link it now. YouTube, I just gonna link this, post the video, copy. I'm gonna post it in the chat. If the chat wants to come back on my screen, discussion here. Oh, take the second. Wait. If I do, sorry, it starts at one, copy, take this. So the second link. So this is it's basically a small video to show you how to install Tapeworm. Basically, Tapeworm is a small plugin that will grab all your images and create GIF or animation or videos out of it and some stuff like that. First of all, like in the video, I go through how to install Tapeworm and then install a small software that needs to be somewhere on your computer, right? It's a completely trustable software, I want to say before. It's a software that plenty of huge company uses. Actually, the website I showed you, SGIF, uses that software in the background. Like Twitch uses that software like for all the video encoding and decoding and stuff like that. It's a really, trusty software. It's just that it's a software that runs in command line, so you don't have any interfaces and stuff like that. So, and that's where we use Tapeworm inside of Grasshopper to basically send like instruction for your computer to do. And so the computer will call that software and do stuff that we asked with Grasshopper, basically. Where was I going for this? Yes, so now you can actually go to the package manager, and you can search for Tapeworm here. This is like Mark Differding put it here on the package manager directly, so you can just install it. It's both Mac and Windows. But remember, after installing, you have to restart your computer, but you also have to install this other, like, don't forget to install FFmpeg, and further description in either the link here or on the video that I showed you. Yeah, so I'm just gonna show you now. So I know that this is just maybe just following, just not, but I'll just show you how quick it is to just get a GIF out of it. So we have 3 types of components. We have basically here IO. There's only 1 component in that section for now. We have a few settings here. So basically what you want to do. And here is actually sending that information to your computer and this software that is in the background. And these are 2 different ways. So these are the plugins that you want. And so this basically makes the tiny worm or snake. And it asks for a source path. So here you want to file path. You want to refer to, you have all the information if you hover the mouse on it. I believe you can also see the code if you want, if you're curious on how it works. There is also all of it, so it's Python work, so maybe easier to get. So sorry, I went too quick. Maybe here you want to select one existing file and you want to refer to, so here in your folder, all files, you want to refer to the first one. I think you can select any, but it's better to select the first one. So what it did here in the background is it created some sort of, basically it recognized the number of the files. And so it already knows like the numbering of them because it compared all the files that are in the same folder, and it knows which one is the first and how it goes. Here it might seem obvious, but sometimes the numbers are really tricky when you have dates as well in it. So it can happen. So, and we want also, but let's leave it like this. Just have this. You can set a target folder if you want, but you don't need to. And then, yeah, you have IO here. You connect the IO to the IO for the setting. And here you have a bunch of default values. Since we have only 100 frames, I know that it will appear too quick at 30 frames per second. So I'm just gonna lower that a little bit. Let's do 10 frames per second. It will already be fast. And then we connect the settings to settings. Here we have, we need only a button. The button is to send the instruction to the FFmpeg software that is will be installed on your computer. So when I click this, there is also overwrite if the GIF that will be created already exists with the same name, then you have to also overwrite or change the name. You can have a target file name. By default, it will take the name of the first image. I mean, the name of the images, right? So I just click on this, and then there will be, yeah, on my second screen, there are windows popping like this. And it's already finished. It's quite quick because there is not a lot of animations, but basically these window, you have to let them go. Sometimes it can take a little bit longer if there's a lot of colors, if there is a lot of images, and you come back here because we didn't say any target folder. It means that it creates the GIF in the original folder. And so if you double click on it, you have your animations already in here. Yeah, and I don't know if you noticed, I will just tell you a little trick. It's that usually in your animations, like if you loop animations, you want the first frame and the last frame to be the same, right? So if we go here just quickly, we can see that if we are at 0 and at 1, you will see that the image should not move, right? You see, it didn't move. I will go back to 1. The image, like the camera position and everything, doesn't move. So that means that it will appear to be completely looping since there is no reflection with the lights and stuff like that, okay? And no really shadows in this case. Okay, great. But if you, here we're creating a GIF and where the first image and the last image are exactly the same. So it means that it will create some sort of pose on the first frame. if you look again at the GIF, let's go again. And when the glider will be somewhere here, the one that is above, you'll see it will stop a little bit. So closely now, it stops a little bit. So this is also a handy little trick here. Start frame, you can say, oh, I want to start actually not at the frame number 0, I want to start at the frame number 1. And so here, if I want to send it, you see it doesn't want because it already exists. So I can overwrite, send it again. So I have my windows popping off like that, up, it already goes. And now if I double check, when it comes back here, there will be no. So yeah, really, if you want to create animations, I really like here. No, there is no pose again because the last and the first image are not the same anymore. I mean, you know what I mean? Like all the rest is like at the same position. We just really don't have that duplicated frame when we create the GIF. All right, so that's it for the animation with Grasshopper. So I highly encourage you, if you are into GIFs and videos and stuff like that, you can create basically here videos, MP4s, other formats, AVI, any others. There are a few of them. Then you can also convert GIF to video, convert video to GIF, convert a lot of frames into different format of frames. So for example, PNG to TIFF, for example, something else. It would be actually weird in that direction, but and then you can also extract all the frames from a video or a GIF. So you can have a video and decide to, oh, I want to have one particular frame. And so you can extract all of them and then select the frame that you wanted. All right, let's dive into V-Ray because this is one exciting part. So we saw here that we have some geometries, we have some pipes, and we have some gliders, right? So what I want to do, I'm just gonna go full screen a little bit. It will be easier for me to grab the V-Ray tab. So here it is. We want basically to convert our geometry into, so the Rhino geometry into V-Ray geometry. Basically, V-Ray geometry has to also have like a texture linked with it, right? So here you have a V-Ray geometry. We will bring it here in the component, in the group 70, and we will connect our columns and also our gliders, right? There is an option if you want them to be visible. It's something that can appear as you go into the animation. You can also change that, you know, as you go into the animation. It can be dictated by the animate slider, but let's not get carried away. What we want here is to add, like find a material. So I think, I don't know if it's the case still, but usually V-Ray, when you install it, this V-Ray for Grasshopper, so V-Ray for Rhino, basically when you get V-Ray for Rhino, you have the Grasshopper as well, the Grasshopper plugin, is to, we can hear, it comes basically with a bunch of materials already, like a first library of materials, right? And so we can here with this component, V-Ray materials from file. If you basically here, you can download any or buy any materials online that are compatible for V-Ray and right click and set one V-Ray material. But as you can see here, there's already like a library material, right? And so here you can select which material you want. I'm just going to check what I selected. Oh, I know already what I checked. So yeah, here I call this columns, but let's call it rails because it's the rails right now, right? We only did the rails for now. or all geometries, all pipes. My bad. And so we will here select, so for the pipes, one that look good, I mean, that I like, it's really subjective at this point. You go to libraries, metal, and then here you can even go further down here, down, and then steel blurry, VR material. You connect that to the material here input. Basically here in V-Ray, a neat tiny little thingy is that when there is a point like this in front of a variable, it means that it is a V-Ray component that you have to feed it with, right? So we're gonna take another one. So it's this one, V-Ray material from file. And for the gliders, let's take one that I like as well is plastic. Not that I like plastic, but you got it. It's plastic translucent 01 white. So it means that it's plastic that is a little bit transparent. Like, I don't know if you probably ever dealt with like hot glue sticks. It will look a bit like that, you know, like a little bit transparent, but not really transparent. We connect it to that, and then we can simply merge this. And these are all the geometries that we will need for now for the render, right? Okay. So now here, so we will set the camera, right? When dealing with V-Ray, I would highly suggest you to go back to the animation slider that we used to have, we used to use, right? And I would suggest you to disconnect it and connect it to the fraction of the animation. Let me explain exactly what it means. Here, I might just take this off because it might just showing that it's important, but is actually hurting the vision of it, I guess. So there is this component that is usually longer like that. It asks you how many frames do you want. So at first it asks for 30 frames. And so you will be able to move. You see, it acts like a slider, and then it stops at 29, right? 0 to 29, it means 30 frame. So actually this is better than the animate slider. Anyway, so we say here, but let's say we want, I don't know, we said we want 100 frame, right? And so now you see that this will go from 0 to 99. And so what's the value here? It's basically exactly the same kind of value that we had with our slider, right? It will go from, oh, my bad, this one has to stay at 100, yeah? And this one has to go from 0 to 1, okay? Whatever the number of frames that you want. So this is why I also recommend to have a slider 0 to 1. So now, now that you connected, now that you connected, basically you don't use this slider anymore, you use this. It means that if you move this, now it controls the camera, right? Because the value is coming from there. All right, so if you want only to make one render, you just, I don't know, like position it like so. And then you will be able to do a render. So let's go to the end. So yeah, you have to keep in mind that the V-Ray component, let's go directly to the 73. So the V-Ray render component is this one. It's not that one. V-Ray render. I got debated by the teapot, which is usually what renders stuff. Here, basically, we have already, you see here, some of them are points. I have points in front. It means that it needs to be V-Ray components. So we have already V-Ray geometry, right? We will do the lights and stuff after. We have the timeline. We don't really need it right now, but I believe it's maybe better just to connect it. It's not really needed. And actually right now, it's already ready to render something. I think so. If I just right click on it, I think there is already, yeah, there is already something happening. So simply right click, render, and it will pop up this. And then you can, like if I move in my Rhino viewport, you can see that it will create a render. So for now, it's quite ugly, or I don't know, like not crazy, not really impressive or whatever. Here you can see I stopped the animation, the render, so that it doesn't run in the background. Here, let's change the way it renders, because I don't want it to be like interactive. You know, I don't want to move around. I want to pick like a direction and then make a good render out of it. Right. So here you can right click on each of the input here above and say extract parameter. It's basically something that you can set with a a panel, and you write, oh, I want CPU rendering, I think. But let's just extract it simpler. Extract output image. We don't really need it for now. So I extracted all of these. These basically ask you what you want to render with. I don't know why you suggest RTX. I don't have it. But from experience between CUDA and CPU, usually CPU is actually faster with V-Ray. It's maybe because my card is a bit old, but it might also be more optimized for that. Here you can select the mode of rendering, interactive or production. And then you have also the how it renders it. If it's progressive, so it means that the whole quality of the render will go better as time goes. Or bucket. Bucket is basically, you might have seen that already many times on renders on someone else's computer, is like all these small square where the computer is currently calculating. Let's have a look. If I render this again, you will see all this small square, which is basically where the computer is computing, right? And so this is already different. So you see that the render is finished. Like there's no computing as of if you were progressive, it might continue a little bit longer. All right. So right now it's just taking the view of whatever view we are in here, right? So if I go here and I do render, you will do this view. So that's not really what we want. We want it to be aligned with the animation. So for that, we need to set the V-Ray camera. So V-Ray camera is right here in the render V-Ray camera, and functions like almost the same. You can see there is a small preview here, which is actually, yeah, let's not move with that. But which is actually, yeah, it works exactly the same. So you have a position of the camera, so camera and position, right? So you can see it right there, and then a target of the camera. And so now the camera will be looking in that direction, basically, right? So actually the pipes appear to be connected. Not really, because this has to move a little bit further. So, yeah, here you want to say if wait, where is it? No, it will take the, here you can say extract parameter, sorry, on the type. and you can select orthographic view. And then I believe that, yeah, you can tweak some stuff. There's plenty of things to do. So I told you for the, when you render with Rhino and Grasshopper only, you have to zoom in and out in the parallel view to set like the distance, right? To set the size, but like it's a distance, but it's more like a size in the parallel projection, right? And here, actually, how you control the distance is with the orthographic zoom. So here it asks for a value, which is a bit confusing to me, but I don't know. It's so it's fairly small values usually. So let's go with something like this. You just have to go with it. You can tweak it whatever you want. You can also have zoom going as the animation go. You could have this value like moving, changing over the animation if you want. Let's have a look. So yeah, if I, whoop, this is not a right click, render. And so now you can see that the animation is like the render, sorry, is at the exact same position as it is since of, oh, okay. So my audio might be like a bit suffering when I render. I'll try to speak less when I render then. So even if I move here, if I do the render again, it will be. So I forgot something really. I forgot to set to continue the camera here, right? And to connect the V-Ray camera to the camera of this component, right? So now even if we are like in the wrong view, as you can see, it only takes the camera view that was set up. So you want also maybe to change the resolution of it. If you want a square, you can, I don't know, just take 180 times 180. So I'll just do 180, 180, and then double click, make it a double, okay, double a list basically. And yeah, I'll just go low because I don't want the, here's the quality. Yeah? For Instagram, if you want, like medium is way enough. High, you don't even want to consider it unless you go like for printing stuff or being able to zoom really and high. But it also not only, I mean, sorry, apologize. There is a mistake in what I said. Obviously, this will allow you to have a better quality to zoom in, right? But the quality here means basically the reflections, the lights and stuff like that will be like the number of a ray of light that will be, you know, that will ricochet. I don't know how to say that. That will bounce off the materials. It will basically be better calculated. So it will be a lot heavier to compute. But yeah, so for me, low quality just to show you, but you can go medium, maybe medium plus, and it's enough for Instagram. So these are for simple image. What we're gonna do here is quickly add some lights, a light rig. And so light rig is basically the environment, let's say, like not really the environment, but it's the the method of the lighting system, let's say. And then we're gonna also put some custom lights and make a render out of it. So let's take, so there is 3 light rigs, and you can only choose one of them, and then you can add as many lights as you want. So which one? Let's take this one. So it's the one sun system. So what I want is basically to have a black background. I like that a lot. If you don't want a black background, the best is to use another one, another light rig. I think it is this one, because you can set colors and stuff. But then, yeah, the light, really, the light will be different. You just have to test on this and see. I don't really have any more explanation on that. We just test and see what's the best for you. Here, a nice little trick is that if you position the sun with the same camera and target position, then you will have a black background basically with this setting, with this setup, with this light rig. While it will also allow us to have like a good colors for the lights that we will add. You will see in a moment. So let's just use the sun position with the camera and the target. Right, so we put the sun at the same position as the camera, right? You can see here. And if you want other colors as well, you can add a background, right? You can add a background, like a shape curved background, for example. But it means that as the camera moves, basically you have the background has to rotate as well, right? Because otherwise the background will be also in front of the camera. That you will see your background, you will not see the geometry. Here, swatch. Let's put this a swatch black, and I put these two here. And then sun intensity here, we will put it like a really low value, sorry, 0.05, for example. Right now it's set. It's a bit higher actually. We set it a bit higher. We can let it like that. I believe it will be. I believe it will be fine. Let's send this, and now we're gonna create some lights really quickly, because we don't need actually something complicated to have something that looks good enough, let's say. So I'm calling this component, which is basically having like a rectangle of light, right? It's something that is really common. You have also like small spheres, and you have also direct, so that will act more like spots, but like a sun, like a second sun, let's say. But with these lights, you have intensities, and like if the light source is closer to geometry, it will be, the light will be more pronounced, obviously, and if it's further away, it will appear less. The light will be more dim. Yeah. So we will just create 2 points. We will create basically a light that is above and under the construct points, right? And then we will create a slider that will go, I don't know, from 0 to 100. So let's say 50, and you have already something that goes there. And we want to merge that with a negative component. So what it will do, if we have negative and positive, it means that we can create a point that is above and under as we go, right? The thing is that you can see that it's more towards the bottom. Okay, so it means that the animation is basically happening somewhere here. So it means that if we do that, this light is way closer to the geometry, and that light is way down there. So let's just also like add here another value, let's say like so, and we connect that to the Z. And so now we can also like reposition it a little bit. You can also like do that like really in controlled way if you want, so that if you modify it, it will always update and you don't have to readjust. It's just that the lights usually it's I mean, it's always good to just test different things. So you can also, like for example, for some animation, for the last one I did, I made lights that move as well as the animation go, and so they rotate around, and so it creates some sort of changing colors on the geometry. So it's really easy and really good thing to do. So we have the positions here, and so as you can see, they point downwards because they by default, because the target by default is the center, so it's 0, 0, 0, right? So we will leave that to it for now. Here we will say invisible by default is false, so it means that they are visible, but we want them to be invisible. So it means that if the camera look at it, we won't see the light source, but we will see only the light on the reflections of stuff, like on the geometries. Okay, and let's just create also like a list with 2 colors. So we're gonna get a swatch component, color swatch, duplicate it, connect it here, and you connect it to colors. So we have 2 points, we have 2 colors. We have to match these 2 lists, right? If you want 70, you just have to have 70 colors. And here you can just, I don't know. The one I did, it was something like this, actually reversed, but that doesn't matter. And the other one, let's say, I did a purple one like that for a workshop. And then here the UV size is just basically the bigger it is, it basically, let me show you. So right now the value is 2. It is basically, you know, make it bigger so that the light that is emitted is higher, like more strong. You can also here set the option to the shape and say, oh, I want a disk. I mean, doesn't change much, but yeah, it can be handy. And so it can be ellipses as well, right? So let's just see what we got here. We connect everything. We have the lights, VRL lights, we have the light rig, and now we have to connect them here, right? Light rig, light. I'm gonna save and render. So that's how we create one image, right? You can see here we are maybe a little bit too close to it. So what you want to do basically is the orthographic zoom. What do you need to do is to go, you have to go higher or lower. I've never, the opposite. So a lower value will mean that you will be further away. So if you put smaller value, I'll try to remember that for me as well. And so you can have like something like this, right? And so if you were to run, I forgot that it might, like my microphone might stop when it renders, but so yeah, if you were to render an animation, it would use also the orthographic zoom to set the distance, right? So this is how to render one image. Okay, that's great. I'm gonna here lower the resolution, okay, just to create a small animation, just to show you how to do. I will divide it by 3, so it will be really small resolution, like 360 by 360. Okay, so if I render that, it's really ugly, but at least it computes fast. And then basically you can right click here and render animation. simply as that. I don't remember. So I'll just lower the number of frames, right? So here I will say, oh, I want 5 frames. Okay, so if we look at it, it will basically do this, this, that, then this. Okay, so really just 5 frames. And let's see, here you can also set a path of where to store the images. So actually, let's put one path. So let's put this one. I'm gonna delete all the images that I have in. And I'm gonna extract the parameter like we did before here. And right click, set one path. All the images, perfect. We want them in PNG, why not? You need a name, so name. And you can render the animation. And so it will go through all of the images. It will move the timeline by its own and create all the frames. So I might have, I don't know if my microphone cut it again, but as you can see, it will move like the timeline by itself, and it will render the images and save them to your here. So the thing is that, yeah, I selected the PNG format. So actually here the background is black, but it's basically transparent, right? So here I believe these images, the background is transparent. So if you want it to be black, you just have to go back onto your Rhino here and select one path. And here instead you select, for example, JPEG. And when you will render, it will be black. All right, so these are the images, you see, with a black background. And so yeah, that's it, how to render animations with V-Ray, basically. You just put more frames. So don't forget, here we have the timeline that has to be connected, right? This is the timeline that goes up to back there, here, timeline. And so basically it controls this. And so here, if you say, oh, I want 100 image or 500 images, it will render 500 images. It will just take some time and make your computer not happy for a little while. Also remember that this actually, you might also want, I should maybe have done that in the code. So it's something that is not in the code. So for the ones that made it up to here, so it's the group number 19. You want to connect this. That will be ugly. All right, let's do it. I might also change it for and I will re-upload the file for the ones who want. Because here we create, like, remember, this is to create like all the positions, all the possible position of a glider, and then we simply select through all the positions. So for now there is 100 of position, so it means that we can only do maximum 100 images, right? And so here, if you put 500 now, it will create 500 animations, 500 images. You can also do something really neat, is that if you want to say, oh, I want only the images between the 20th and the 30th, you can do that, and you see that there is here some interval appearing. And so if you were to render the animation again, it will only render from the frame 20 to 24 to 30. Sorry. That is it. a small little detail is that something that I've started to do now is to stop rendering on my computer so that you can also render it on the cloud. It's a paid, so already the plugin, obviously V-Ray is a paid plugin, right? But like there is a free version for with a time, like a time limit, right? And but you can also render on the cloud, which is a paid version. I will just show you how to do it. It's really quick, but bear in mind that you have also to pay for that. And it's basically the time it needs and the number of computers that it requires to render. So it will estimate the price that you will have to pay. It's not really clear, so you have to buy like credits online, and then yeah. And so there is the V-Ray exporter here. You basically want to connect the scene here to there. Wait a second, I'm just gonna remove something here. It's already removed, perfect. So I go back here. You want to have an output file. You can extract the parameter and set one path. Let's say here in the like all our image folder, let's say my V-Ray scene. Tired. It's not even my V-Ray scene, which is in the folder, right? And so we right click here and you can say export animation. When you do that, it will take some time because it will actually create, it will like register all the geometries, all the texture proxies and stuff for every frames, right? With all the lights and stuff. It will not render it yet, but then it will create you, like give you a little file that will be a scene, like a V-Ray scene file. And that one, when you go over the V-Ray cloud service, it's a V-Ray. If I put cloud, yeah, Chaos Cloud Client, and then it will pop up like here, and it will ask you to select a scene, and then you can select that scene, and it will present you with a like oh, this is the recap of your scene. Do you want to upload and start rendering? Yes, and then you start rendering. Basically, it's really that easy. It's a bit expensive sometimes, but it's that easy, at least to use WebGL with V-Ray and Grasshopper. I have to say, I don't really know what you mean by that. So yeah, I don't know if I can, I cannot really answer it because
I think that's what Shape Diver is doing. You can't really do it right from.
Sorry, what? Sorry, I didn't hear what you were saying.
You can't do that from Grasshopper.
Yeah. Yeah.
Like on like web viewing.
Yeah, I see.
That's what like Shape Diver is doing.
Yeah, no, I don't think so. I mean, maybe in the future, I don't know. So that's it for the V-Ray part of it. So really, either you do it on render animation here, or you can export here, right click, export the animation, right? You can also export a simple image, which is the current image where the camera is pointing at, right? With the right zoom. And that's it. So yeah, that's all I wanted to cover for the V-Ray part of it. So all the lights, the camera, the textures a little bit, and yeah, light rig, and how to render different ways of rendering. Not to kill your computer with the current prices of the graphic cards. That's basically the only reason why I would use maybe cloud sometimes, is to be kind to my poor graphic card. So I think that now maybe we can, for the remaining people, I've seen I saw the number going down a little bit. Like, I'm sorry for overextending. I hope I hope you still find it interesting. There is these two parts that we can cover now. Go over them, and yeah, and maybe like if you have questions again, just keep we here. That's good to know. Thank you. Yeah. Don't hesitate to rewatch and ask questions. Really. Let's go ahead and cover maybe this. Is it okay, Michael, if we?
Yeah. How much time do you think you need more?
I don't know. This should be a little bit like, it's more complicated stuff, but since we only go through it, I believe, like, I don't know, 20 minutes. 20 minutes.
Yeah, it would be good then.
Yeah, should be able to do it in 20.
Okay.
Great, let's go then. So I'm turning everything off and I'm going back to wireframe view. So yes, I'm gonna disable here. So this is the completed version, right? Completed version. So there is no numbers into it. So you will have to kind of find in which group we are. We will go through all of them one by one. I'm gonna disable the camera movement so that we can change some values and it will not move us around, right? So yeah, so what we start here. Actually, I prepared this. Let's go quickly. I'm just gonna go very quickly into the PowerPoint, and then we're gonna cover. So here we ended up with this. Basically, we have all the curves, right? And what we want to do is create potential columns, that will be in the background and that will at some point in the video create the illusion effect that we have here of the column connecting with the remaining pipes. So for example, here the glider is going through this. And so it means that at this point, all the remaining curves will have like columns in the background that will like connect them to the top and to the bottom, for example, like infinite bottom, infinite top, right? So we will start by getting all the planes that are at the ends. We will have vectors, like z vectors. We will set them to be in the continuity of the curves. Then we will move everything, all these points, with the camera direction that we had before. Remember, 4 direction of the camera. Here we see 3, but there is also one in the perpendicular to the screen, so that's why we don't see. And so this is what it looks like. So it looks really ugly, and we created too much planes. So we will filter a first part so we will filter out the ones that would not be good potential columns, potential like direction for the columns. And then from that, we will start creating some lines based on it, based on the orientation of the planes. And then it will create something like this. So we have a bunch of columns. It still looks really ugly. Basically here, we have columns for every connection at every direction of the camera, which is not what we want. So what we want now is to filter down to just one point of view, and we can select which point of view we want, and we will have column for that point of view. So we can start again with all the columns. We will have, and we will be able, like here, like you see, all of the columns, and then we will be able to select one point of view, and we see that we have connections. You see that all the lines here now are connected to some columns, right? And so if we select a different point of view, like we have columns somewhere else, but when the camera will align in that direction, they will appear to be connecting to the pipes. And then we have another connection, and then we have another connection. Basically, we have 4 directions, and so we have 4 potential columns. We go back to the first one here, and yeah, so we see though that here we still have a problem in some cases. Yeah, we see that where there is the connection happening, the transition connecting here, where the gliders are going through, there is also columns that are being drawn here, right? And so here, imagine that if we pipe all of these, it will like appear odd, like, right? And so we want to select these and delete them, basically. And so after that, we are having all of that. And so these we can select and filter with only data tree structures. So that will be a bit complicated with the path and stuff, but hopefully like the explanation, the quick explanation I'll do here, and the info panels will help you out. And if not, don't hesitate simply to change some values also as well, just to see, and then we can also discuss it, like if you need more info afterward. So we had all the curves here that I'm just gonna show you all the curves, right? We had all the curves. And what we wanna do is find the end planes of the perpendicular planes of all these curves at the end of it, okay? We don't care about the X and Y direction. We just care about the Z direction. So some of these planes have, so if I display here, we display really quickly, we have some planes that have directions that goes inwards to the curve, and some of them have directions that go outward. But what we want is the columns to be further away from the curve, right? We don't want the column to be in this direction from the curve. For the illusion to work, the column has to be in the other direction. Okay, so first here, what we do is we reverse some of the planes that have their normal, the Z vector in the wrong direction. So if I go, yeah, I cannot show it like this, but basically that's what we're doing. Sorry, I have to go a little bit quick, as you know, otherwise we will not make it in the time. Oh, it was here. So here you can see that now the vectors are going outward everywhere, you know, at every curves it's going outwards. Okay, great. What we create here is a bunch of vectors. So we take the vectors, the direction of the cameras, okay, the 4 directions that the camera has to align itself to, right? And here I basically create a bunch of random distances to move. We will move basically these planes. Like, let's select this plane, this one, and we will move it into the 4 directions of the camera, the 4 camera directions, okay? And with a random distance. So this is basically what these randoms are. You can tweak all of that. We multiply it by the vector, so we have a vector with a length, random length. As you can see here are also, so these are is unit vector, and here I also created vectors that are reversed. And so we will see right after that sometimes some columns will appear to be a bit odd when it aligns. And so basically what we do here, we create vectors for all the 4 camera directions, but also for the reversed vectors of those camera directions. It will make more sense after, I'm sure. So we move all the points into the direction of the camera and also into the opposite direction of the camera. So like so. So we have it's a bit not really understandable like this. We cannot really make something out of this view. Yeah, here you have to pay a little bit of attention with like the data tree. But yeah. After that, what you want to do is basically evaluate, for example, let's take only these, okay? Evaluate these planes, the origin of each of these planes, okay? The points that are in the center of the planes. And you want to evaluate these coordinates. So they are in data trees, huh? You want to evaluate these coordinates into these plane system. So here the points, if you simply deconstruct the point, deco point, you will have, you're not helping me here. This one, you will have X, Y, and Z values, but it is based on the world plane, right? Here with this component, what we do, so some of you, if I don't know if you had access before today, some of you might have another component here, which does basically the same, but I believe this one is more understandable than the other one. Yeah, I overcomplicated myself again, but so here basically we will feed one plane like as a world plane, if you want, and we will evaluate the points on that plane. And so you see that we have 30 branches. We have a certain amount of branches we can check, but the number of branches are matching, and so we are testing 4 points onto one plane every time. Okay, because we moved the plane into 4 directions, because we have 4 camera directions. So it's a lot to get, but that's what's happening. And so we do that also for the other one, right? For the others, and so we evaluate on the same planes, but the other points, the points that are basically here. Right? And so this will allow us to basically so we created basically twice too much potential points for the beginning of the columns. These points will be, you have to have in mind that these points will be the beginning of a column that will, for example, go up or go down. And then when the camera aligns properly, then it will connect with a curve and a column, for example, okay? So these are the potential candidates. Now we have to define, to see which one is the good one, if we have to take the ones that we have been created in the direction of the camera or the ones with the reversed direction of the camera. So here it is what we basically do. We will see the Z value of the planes calculated, like the Z value of the points calculated to these planes. And if the Z value is positive, remember the Z direction, we oriented it into this direction for all the planes. So it means that if the Z value is positive, it means that for that camera position, the column will be into that direction. So in the good direction, it means that the column will start somewhere in that direction and go somewhere else. So it means that if you align it, the column is like, you know, in front of the curves. If you look from this direction, and if you look from that direction, the column will be behind. Like you'd have to follow the arrow. I will show you a really small, tiny thing here. I explained that you can also just just to see here, like we select the best candidate, but you can also see that I prepared this one. If you replace by this, it creates ugly stuff. Like it still aligns, but we will see. So here we end up with all the potential good starting points for our columns, right? So from that here, let me just disable these. So we finish this one, we go here above. Here is also like a small tweak that you can play with. Basically, it will check for the plane of the columns. And if the, I will put the camera because I want to explain with, if that's fine, I will explain with my hands a little bit. It might help to understand. So if the planes are facing upwards, right, it means that the column that we will create will go upward and then go up like that, okay? And if the plane is facing a little bit downwards, it means that the column that we will create will go down. And so here, I basically created a small group that allows you to reverse that. So it means that if you have a plane that will be facing a little bit upward, like in any direction, but upward, it means that we will create a column that will go in that direction, and then that will go in the opposite direction. It will just create a different visuals for the columns, right? So here we're just creating vectors, and you can see that some are facing into one direction and some are facing in the other direction. And here, based on the orientation of that normal vector of the plane, so the ones that are above or smaller than 0, we decide to inverse yes or no. And in this one, create some random values that will set the distance for the column that will be extended before dipping up or down and up. Yes, so it means that here we create random values, which are which will be the so basically the column we start here. So you have the column here that will start. This is my column, right? And this is my plane, and this is my curve, my rail curve, and my plane. So they will be like this, not touching. And when you align, it will appear like they, like when you align the camera, it will appear like they are connecting, right? And so here, this group, what it does is that it starts from the plane of your column, and then you have a random distance going into that same direction of the plane, in the Z direction of the plane. This distance is randomized here, and then it will go up or down based on what you decided above. In this group, so there is nothing really to see here. I mean, it's just a bunch of vectors. Yeah, display vectors is something that can help here to see a little bit what's going on. Once again, the data tree looks a bit like a bit tricky. I explain a bit later, like what's all the structure, like with names, so that you can see and also select maybe in the data tree to see yeah, how it's organized and how we filter them later. Here we gather the selected starting planes of the columns, and we start creating some geometries with the vectors that we created. So the ones that will go up and the one that will go down. Here is just a column extension is in the vertical way. So I just put a high value so that I'm sure that it will go really far above and under, so that it will not fall away from the screen. You will not see the end of it when you run the animation, if that makes sense. Since we're on parallel projection, you might want to sometimes go really high. That's why it's like a lot higher than what's usually the sizes of the model. So here we basically, from that, we create a bunch of points, right? With see, this is the value I told you. It's the Oh, I shouldn't have moved that because I have my pipe that is being created. Let's just disable that. So I'm back here in this group. So you can see that these are like, we want basically the column to go that high and that low. And from that, we create some polylines, and then we make a fillet out of them. And so you can see here's some geometry, that will be the columns. These are all the columns that are possible for the animation for all the different. So that's a complete mess. We don't have actually, I tested an animation with that. It looks ugly. But look here, the inverse the direction of the column. So if the plane upward, we can also say no. And so they look more, you know, like more, like basically if they go up at the first, if they go up, they will continue going up, right? If they go down, they will continue going down. And if you inverse this, if they go down, they will go up at the end, okay? So this is just, yeah, a small option that creates some variation. And the fillet here, you can change, and it's change the fillet. Yeah, that's a pretty, that's pretty nice. Let's go ahead now and do the final groups of component. The final groups of the definition. So we are here with all the curves, right? What you might, I mean, if you are extremely aware and you can follow like this without testing on your side, here you might have to trust me on this one. We have basically created curves. It might not appear easy at all, but yeah, let's look at this one. This one is nice. We see that we have a column that goes down, and then 1, 2, and 3, like corners it makes, right? And it's because we created, you remember, 3 groups of curves at the very, like in the middle, in the blue, dark blue groups. So it means that here, this line on this part, it's duplicated, right? Because this line goes up somewhere there. And then the second one goes also up somewhere there, a little bit higher. And then here we have 3 times the curve going on there, and it stops a little bit higher. So if you were to like make geometry, like pipe geometry out of it, when you render it on V-Ray, it will be disgusting, because you will have like a texture over texture over texture, like 3 times. So it will like flicker. It will be not good at all. So what I'm doing here is that I'm breaking all these columns, and I want to extract only the vertical lines. So here I'm just selecting by the index, because we created the curve, these curve in a direction, right, from points. So we can just select with an index, which is basically -1, yeah. So let's turn off this. We only have vertical lines, vertical curves. And here, like that's where I told you that the data tree structure was a bit complicated. What we want to do for filtering, now that we know that we are arriving at the end of the definition, usually I like to work with data trees, because it can allow you to keep order into all the data that goes into your definition, and it allows you to retrieve information faster later on, rather than like testing some physical intersection between curves and stuff like that. So you can really use the data tree structure to like, yeah, to basically filter and keep what you need, or select some stuff that you need, or make masks like I show you, like we saw earlier. And so here we have like a bunch of, we have basically 5-level data tree, and we want to reduce one order, because it's something that we like this level of structure, we will not need it for the rest of the definition, because we know that we are arriving at the end, right? So here I named for you what is, to what corresponds basically the numbers into this data tree structure. It's something that you can test. I believe I gave you here, for the ones who have Wombat, the plugin Wombat, you might have this. This is a small component. I will show you when we arrive here. And so yeah, here basically, if we look, we don't need the height of the structure of the curve. So columns, curves, height, column, curves, height, sorted. So this is why here I basically remove it from the structure of the data tree. So I simplify one level of the data tree and I simplify the one that was B, and the B corresponds to this. You can see here there's no B anymore, right? So now the info that was in this thingy is in the list. You can see there is 3 items in it, and before that there was only 1 item. And I do the same here for all the rest of the curve, the remaining parts that are these tiny little, I don't know how to say that. All right, so here, remember we have 3 curves. What we want to do is select only one. And so here, I'm not gonna go through which one we have exactly to select, but basically, yeah, let's go right quickly. Because we have this really handy one that is here on the right. Basically, for this one, you have to see, like, these curves, they go up, okay? And what we want is to select the one that goes the lowest. Why? We want to remove basically the one that starts here and goes up, and the one that starts here and go up, because the one that starts the lowest will already make up for these 2, right? Since this one goes there, goes through there, goes through there, it means that we can take the one that starts the lowest. Okay. But for the ones, the columns that go down, we want actually the highest one. You can see here we have 1, and then 2, and then 3. So here we want to select the highest vertical curve. Yeah, so basically that's what we do in this component. So here there is only, it looks like the same, but it's only one curve now. There is a lot of curve less. In the next component, so yeah, here we split based on the one that goes up, the one that goes down, and then we clarify, we select the first. In one type of list, we select first, and in the second type of list, we select the last one, which is whatever the one is lowest or highest. Here it's just because the data tree structure was easy, like was not easy, but structured, so complex actually. And that's why we can simply retrieve it with this. We don't need really to compute, like evaluate one point and test it. Is it higher on this one? Is it higher on this one? You can just select one of them. After that, we compile all of these together. It looks again the same, but actually we only have a third of the vertical lines. We join them back together. It doesn't change anything on the visuals. Actually, I don't even think it is needed, but that's how it is. And here now, we are again at simplifying the data tree once more. So we still have the structure that we had here. So without the B, so the C, when you remove here, it means that the C will become the B for the next one, for example. You know, all the letters will update. So here you just restart with A, B, C, D, because you know that you have a 4-level structure. And then here I get rid of one letter, which happens to be the B again, because we don't need this information. The B, if you change if you, for example, select the geometries for one number on the A, one number on the C, one number on the D, and you just change the value of the B, when you select with a tree branch, for example, tree branch, you create a path and you just select and change the B value, you will see that it changes only like connect to the first or the second base curve. Okay, so it means that it will select the columns that connect either to this or to that. But what we want is the columns to be connecting to both of them at the same time. Okay, when the camera is aligned somewhere here, for example, we want both of these ones to be connected. We want this one and this one to be connected, right? To decoration, to the columns. We want this one to be connected and this one as well. So this is an information like this or this is something that we don't need anymore. So that's why I get rid of it here. And so we're down with a much simpler data tree with three structures. We have which group of curves to connect to. We still have connect either to the bottom or the top. So the top is that, and the bottom is the end of the start of the curve, the bottom of the end of the curve. And then we also keep the structure here D, which is from which point of view we want to have the columns, right? Because we moved all the planes, remember, with the camera directions. So that's where the camera directions or the camera point of view, like went into the structure of the data tree. And so here, this is our little guy from earlier. We have a data tree, and what we want to do is create basically a certain mask that will, let me show you, that will select only some columns, okay? This is a small component that you have in the file. I realized that I forgot to tell you to get one plugin. You might have Wombat, which has construct mask, yeah. So this basically is the same, and you also have the code if you want. I just did it so that you don't need to install something, and so it takes a list of strings, like pieces of text or numbers if you want to select path index. And it will create a mask out of it. So, and it will like basically also keep the structure of its own data tree, whatever you want. And how do we create this mask? You see the value here. We know that I'm saying that we don't care about the two first structure, but we want to select to select a certain third level structure, right? If we go back here, we see that the D on here has become the third level of the structure, okay? And it stands for which point of view the column curves are for. So here is just
I just want to check how much more time you think you need.
5 minutes. It's really, we are at the end. Sorry,
Okay.
I know it's standing again. It's really complicated to explain this. So basically here, it's we are selecting. It's a slider, and it just allows you to have a Like if you change some values in the definition, the domain of this slider will change. This is Heteroptera again, really convenient. I'm just not gonna speak about that, but here basically what we do is we select which point of view we want, right? It's just a slider. You can have a slider really and just change it here. It's just so that here it always go minimum. It select the first direction of the camera. The last one is always the last direction of the camera. So you can see that here the curves, we select different curves, right? And so this will be for one specific camera. Okay, so now that we have this, we are done with these, right? I'm gonna just quickly put the camera on, zoom a little bit, and go to one point of view. I'm just gonna move it, yeah. Actually, let's stay here at 0. You can see that these curves seems to be connected, right? Now they are not, but if I go back here and put down to 0, you can see that they look connected. And so we know that we are at the camera direction 0. So we're just gonna select here 0. And so it means that for the animation, the columns will align for the camera number 0. If you put for 1, if you move the camera again, if you do the animation, the columns will appear to be connected for the camera number 1, as you can see here, right? I noticed that the camera is also going up or down here. Let's put 0. Okay, and so what I told you here is that, so we are the camera 0, so let's put selection of the camera here 0. You can see that there are also curves that are not wanted, right? Here you can see that the columns, there are also some geometries that will not be what we want. Let me put this on and display them. Here, and I also want to, yeah, if I do this, yeah, so you can see that there are also here 2 unwanted columns, right? And this will happen to every camera that you select. So these are the remaining ones to filter. And so this happens in the last group here, which once again uses the structure of the data tree. So it asks for, here it's just the value of which camera you selected. And here's the number of curve that you have. And so based on that, it will, we create here a little, basically a little, what we do here instead of selecting all the other curves is that we select these 2 curves. Because remember here, the split tree will give you the positive, but also the negative. So it means that if we try to select these 2 curves, we also can retrieve all the others. So here we have 2 lists, like the data tree structure that is 0, 0 and 0, 1 and 3, 1. And so here this tiny component that I told you about earlier creates these 2 paths. And if we display this, we see that we select only these curves that are like troublesome for the animation, right? Like we don't want this, like if you go there, this will go through this, right? And so here we want to select the negative, the ones that are not there. And so up, you can see that they are not appearing. And this will also work for, if you want to go for, let's go to the third one. Yeah, and you go back here and you animate it. You go a little bit through it. Let's make some room. And now so still the column look completely not connected, still moving, still not connected. And then in one point in the animation, everything seems connected. But if you look closely, nothing is connected, right? Yeah, so that's it here. Like all the pipes are already connected to the V-Ray part, so you can already you could already render it. That's it. So I know this last bit might have been like really a lot to get to receive like in one go like this. Yeah, I think even with more time, actually, it's not something that is easy anyway to explain. The best is really to experiment a bit with it, like test a little bit, change the values at the beginning, and then come back here and see what is the new structure and yeah, what are the other options that you have afterwards now that you changed the first ones. And there is also these panels to help you a little bit. And if not, yeah, you can just tell me and I will reply to you.
Cool. Thank you so much. Feels a lot of information.
Yeah.
Seeing everyone was enjoying it.
Yeah, I'm
Very
still
cool.
happy. I'm still happy to see
Cool.
some people. Yeah, it's like, remember when I started animations, it always seems like it's sometimes, I mean, this type of animations is already a bit more tricky than other ones maybe, but it's also, to me, it's one of my, it's basically my favorite with this perspective trick. Yeah, I'm really happy that if you came to make videos out of it, which you basically have to, just tag me as well. You can tag me on Instagram. Yeah, so that I will see them. That will be cool. That will
Sounds
be really
good.
cool.
Well, thank you so much. Thank you everyone who stayed.
Yeah.
When the recording's done, we'll send an email and all that stuff. So, yeah, let's end this thing and look forward to seeing if anyone puts up some animations of their own.
Yeah, that will be really cool to see. I mean, obviously they will look a bit like these ones, but like there is plenty of value still to tweak from, so that's cool.
Yeah.
Thanks again for inviting me as well. That's cool.
It.
And thanks for everyone for coming and for the bravest ones that made it up after what? Oof, after 7 and 20, 7 hours and 20. All right. Thank you all.
See you.
See you. Bye-bye.